This is the Spatial Synthesis V1.0 webinar. It is inspired by our master's degree program, our fully accredited online master's degree program, which starts next year, and registrations are in February. This is based on Chapter 2, Corpus School. And in this webinar will be a small, a very tiny, small kind of preview to that. Of course, this is a 5-hour webinar. That's a 9-month master's degree involved, accredited program. And in this webinar, we'll be looking at Maya and Grasshopper for basically doing polygonal space morphing and unit creation and aggregation. You should have an email yesterday with the download link. If not, I've just put it also in the chat for the supporting files for this webinar. Just to briefly introduce Alejandro, I'll let him, introduce when he speaks, but he is a member at Xamorphine and a senior architect at Zahadi Architects and a long-time tutor for our webinars and workshops. I want to briefly introduce you, if you've not seen before, to our master's degree program page, which you should go check out if you're interested in the things we're doing or interested in a computational design degree from leading professionals working in all kind of top offices and fields, doing this work day to day. The tutors we have on this webinar are they're not just professors and educators, they're people that are, using this for real everyday work. So please go check that out. And Chapter 02 Corp School is what this webinar will be based off, in which Alejandro is also going to be a professor for in that chapter of our master's degree. I want to remind you to please tag us in your posts and stories. This way we can see it. We won't see like hashtags, so it's best to tag us so we can see the stuff, share what you're doing. And also after this webinar, you can send an email to results@designmorphing.com with any images or screenshots that you make from using this workflow in this webinar, and we'll feature them on our website. All that information can also be found in the email that we've sent, and we'll send a follow-up email. After this webinar, you will receive another email once the recording is ready to view the recording of this webinar for 30 days, and you will receive another email which will inform you how to get your certificate. So without further ado, I'll hand it off to you, Alejandro.
Okay, thank you, Mike, for the introduction. So hello, everyone. Great to see people coming from everywhere. Pretty much we have from everywhere in the world. I've been reading through some of your greetings. That's I think it's very exciting, like these online webinars, because I've been, as Mike was saying before, I've been doing workshops with Design Morphing for over 3 years, I think it is already. Now, before we were quite limited in terms of working in the office and also doing the workshops. So we're limited to do 1 or 2 per year because basically our holidays wouldn't allow for more. But now with these online versions of the workshops, I think we can bring this knowledge and research to many of you. And just very glad to see that this is actually having impact, and we're all joining from all over the world. Very rewarding to see this. So I would like to share my screen. I'm going to share my screen. Oh, there is this button of Q&A. So you can ask questions. I can see there is like already a question here. What I'll be doing is I split my, I'll share my screen. And so I will show how I split the outline for these 5 hours we're going to be together. So what I will do is like after every part, I will go through the Q&A, and Mike will be also answering some of the questions as I go through the tutorials. So I can see, let me just share my screen. So I'm gonna share screen 1. Okay, so let me see, how do I get here to see? Okay, I'm not sure if I can, there you go. So the Q&A is here. So you have that option to leave there some questions, and I think this is the easiest way to be answering questions. And I guess after my introduction, after the first part and the second part, I will leave 15 minutes room for questions, so everyone can ask different questions. So is this webinar a small taste of the master program subject, but in which context we will cover this in master program? In master program, we will be learning this webinar's topic in briefly or in actual construction process, etc. So I think like this workshop, it's like the, like I will explain it in my presentation. And basically, like I'll be introducing some of the concepts I'm starting to research for the content of the master. The master, you won't, like you will actually have like a whole thesis starting from beginning chapter 1. Like if I maybe share quickly, well, all the information should be online. So I think like if you go through, like that should answer most of your questions. So, but like, let me type design morphine. Okay, so here, if we type design morphine, so if we go, okay, let me just put it here. If you go to the education, okay, there are more questions before we start. So if you go to the master here on the top, you will see during the master, basically you're gonna have like all these different chapters. So Alexander was covering a first intro webinar for this one yesterday. I'm doing this one, and then you will have 4 more chapters coming. So I think it's Madeline is doing another one, and then Alejandro is doing another one here. And then we'll be doing like I think another round of webinars later in January, if I'm not mistaken. But basically, during the master, you'll be covering with your thesis everything. So you will start from this chapter, and then you will develop in that kind of second term this one, third term this one, fourth term this one, fifth term this one. And then you'll be, I think it's super interesting because you're going to be covering from the very small scale to the super large scale. And then you will be seeing applications of each of the softwares that each of us is kind of expert on to kind of real scale projects. You will have your own thesis, you will have your theory as well, and you will have your different labs where you will be prototyping, and you will be also looking at media, even robotics. You know, we have robotics as well. So it's like full on master covering a lot of things. I think it's very exciting. Like it is something new for us, like online teaching altogether. But I think we had the experience over the last 2 years, and then we're confident that this is going to be actually much more intense than the kind of physical masters, because we are bringing like all kind of our members, or like more, like some of our members from Design Morphine to teach each specific skill. And you're going to have a lot of support, and yeah, I guess like we can cover questions about the master later on. If you mean by construction, like producing construction drawings, I'm not entirely sure how that's going to be. We're definitely going to be prototyping, but like it's not like per se, it's not like you know, like it's not an office project. Like I think we'll try to teach you how to think about all those things. Okay, so yeah, master assume no prior knowledge of computational design tools, so we'll be covering everything from the beginning. So that shouldn't be an issue. We always try to start from beginners and then move on to intermediate and advanced. So, okay, without further delay, like I'm just gonna show quickly how I'm gonna be structuring this. I don't wanna be taking too much time from our teaching, but I'll be answering questions after every break. So this is a little outline I have here. So basically, we're going to have like a little presentation I'm going to be sharing now. And then I'm going to have a little introduction to Maya. We're going to cover in quite a bit actually Maya in the introduction. So I will need you guys to be quite focused on that. Don't worry if you don't follow everything. You're going to have the recordings, and then you can watch it as many times as you want for the next 30 days. So it's really totally fine. Then I'm going to have an introduction to Grasshopper. Like I won't be covering everything in Grasshopper. I think will take far too much time. Okay. Let me close here. So I won't be covering everything in Grasshopper, but I will be like just focusing on mesh modeling and morphing workflows. And then we'll have 3 exercises that have been 3 of the designs that I've been posting to show you a bit like the application of that within this topic of living cells and spatial synthesis. Okay, so one more thing, like I think Mike explained it already. It's important, like if you guys wanna tag us in your stories, like that's my account, and then you have Design Morphine. Here I usually post, so these are all the kind of explorations I've been doing so far for this webinar. This is something I'll be kind of showing more towards the master, or like maybe some other webinar. We'll be doing this one for sure. We'll be doing this one for sure. I think that one, I had a poll to see which one you guys were more interested in. I think this one had a lot of interest, this one as well. And then I think I did also something like that in this direction. So you can also see how we do this kind of mapping of modules. Okay, so I'm gonna close here, yeah, and we're gonna start with the presentation. After the presentation, you can leave questions, and I'll try to cover the questions. Okay, so this is me, Alejandro García Gadea. This is spatial synthesis. What do we mean by spatial synthesis? Is organization of spatial arrangement. So we do design living units or living cells, as we call them, and then we start analyzing how we're going to arrange them and what are the best possible designs for the intention of the user. So this is a little bit of my background. Without like going too much in detail, but I studied in Alicante. I did 2 exchange programs. Then I went to the DRL. I work in Alicante, Barcelona, and then London, Grimshaw, HKS, and since 2017 I'm at Zaha Hadid, and I've been doing like a lot of workshops with Parlet, with AA, with Design Morphine, recently with Mill.com, and yeah, some other small places. So I wanted to add this slide because I know like many of you like ask me about, like background and stuff like that. So basically, I think that this kind of summarize where I am right now. So I had like, my project thesis in my bachelor's. Then I moved to more kind of architecture-based companies, like I did like my master plans, my large-scale buildings, my small-scale buildings. That's more like Rhinoceros, HKS, B720 in Barcelona, and NSAs in Alicante. But then in parallel, I always had this interest on design and research. So at some point, I decided to stop doing this and start looking more into computational design. I was using it already, but like I didn't have the theory behind. So let me see. Is it all good with the camera? I think it is. I just don't see myself. Just 1 second, guys. Mike, can you see everything okay? Okay, let me see the chat. All okay here. Okay, thank you. Thank you, guys. I'll leave the chat here so I can see. Okay, so perfect. So a little bit about my background. So as I said, this is basically it. Like I had like my practice and I had my interest, my own interest in digital fabrication. I worked in a fab lab for a couple of years here and there. I worked at the EA also in the fab lab very shortly while I was studying. And I always had this interest on 3D printing, just like exploring shapes, like form finding, fabrication. And at some point I started teaching as well. And all that, I just felt like it had to be combined with this somehow. And I found this fantastic opportunity to join Zaha Hadid. And I feel like this is the place where I kind of get to combine these two worlds. And for me, it's very rewarding to have this opportunity to, like work in architecture, but still have a lot of exploration in terms of design and concept. And now I think like there is a little bridge in between these two. So I do explore like very different things in my workshops that later, in a way, I apply as concepts at Zaha. And then Zaha also influenced a lot the stuff that I do in my workshops. So I think there is a little like symbiotic relationship here. So about inspirations, that's also another question I often get. So I think like in general, I love traveling and I love like photography as well. Those are not my they're not my photos, by the way. It's just like online. But I think like in general, I just wanted to bring a bit of like a source of inspiration that I find. So nature is absolutely one of them. That's the best one. Then there is a lot of like craftsmanship and ornamentation, like in like I don't know, like I find yeah, like Iran obviously is like one of the main ones, and then like south of Spain. I come from around that region, and I often like find super interesting to see at some of the details and get inspiration from that to later develop some of my designs. So digital fabrication, there is like a lot of people doing super interesting stuff, like from Bartlett to Michael Hansmeyer, Bill, Mark Forms, tons of people. I think that digital fabrication for me, like kind of responding to the question of like, are we gonna do construction drawings? I think construction drawings is not the future. I think we'll be delivering like 3D models in the future. These 3D models, like we'll have companies that produce a G code to like 3D print them or fabricate them straight away. Like most of the buildings we do at Zaha or any of the designs I usually model, it will be very difficult to express on a plan and a section. Like you will need like a lot of drawings, so it becomes a bit redundant. I actually often, even in the office, when we are delivering some of the geometries, like we just like can't submit drawings. Like we need to talk in 3D. Otherwise, it's just like pointless to have that conversation. So I think like, digital fabrication and thinking how you're gonna build these concepts, it's super important. And then, of course, looking at the big guys and seeing how these concepts apply in architecture. I think like those are the steps. I think like it's equally important to observe nature as it is to look at buildings. And often like, you know, like you create bridges in between. So a little bit about Zaha Hadid. So in Zaha Hadid, like I think we have a very like computation-driven approach. We do think a lot about workflow, and we do think a lot about procedural modeling. So I think I'm missing one slide here. Oh, shame. Okay, well, missing one slide. But yeah, basically I wanted to explain, you know, like how we go from concept to kind of construction. So the process usually it's the form finding is the first step. So you can do form finding in any software that you want. You know, sometimes it's through simulations, sometimes it's through just like manual form finding, more like sculpting one geometry. Sometimes can be like, you know, evolutionary algorithms. It can be like anything, like there are many different ways. And I think it's not as important to think about a software, but about the process. So form finding for me is the first one. Second one is to start like creating a parametric model of it. So start thinking, you know, what are the relevant moments of your project? What is like the key features of the project and how we can gain control over that feature, so that later when we have like, you know, like to review the design because consultants need something else or the client wants to explore different options, like we still have flexibility to work with that. And then we have the rationalization process. So that process, it's like I work a lot. I work basically from the concept to the rationalization process. So we don't necessarily, I think like, you know, everyone at Saha had a different role, like very different roles, and they are experts on each of them. I like to work across platforms. So I think that's why my webinars like basically end up being a lot about like bridging between Maya and Grasshopper, bridging between softwares in general. So I think that's where my interest is. Like I like to think myself like as a designer, but also an architect. So I need to know how things are gonna get built. I don't work that much in drawings. So basically I always deliver a detailed rationalized model to Revit, and then there's a Revit team that basically will work out all the drawings. Like there are things that we do to automate that process as well. So we do automate like the transfer between Grasshopper and Revit. We have our own workflows, and that's something we do as well. But basically from Maya, thinking the geometry through, thinking how we're going to build it, starting to rationalize and create like a bunch of parameters to control our building, and then have like absolute control down to the millimeter for like right now I just submitted like a 4 towers building, and it was all within one script. So I could, you know, we will change build ups and like I will just be able to update it. So it's very important to know that, you know, Maya, I think is the tool for me to sketch and to think about ideas, think about the key features, and then you move on to something where you can have control, call it Grasshopper, or I think like some people use Blender as well, or any other software. But you need to have that control if you want to make it a real project. I think that's very important. So you can't just stay in Maya. There's a point where you need to have that control. And that I do it in Grasshopper myself, but some other people do it in other software. Totally fine. So yeah, so there's a question about like if Zaha use Rhinobolt. There's a Zaha Code research group that is very close to Rhinobolt. We have to block research group. So Rhinobolt, we have our own Rhinobolt in Maya. And yeah, that's the one we usually use. But we do a lot of collaborations with block research group. the sensor for modeling, or can we use other 3D modeling software for today's examples? I think Maya, for me, why are you using Maya instead of other softwares? I think, like, you know, you could use other software. I don't see why not. I use Maya because it's very fast to model, and you have the CAD-MUL algorithm within one key in the keyboard. So it becomes very fast to model and explore things. And I think there's a very good workflow between Maya and Grasshopper, Maya and Rhino, as you will see. Okay, let's keep going. So I think another important feature of another important element of the work at Zaha is to understand that the features of a building or the features of a design, it can be explored at any scale. So parametricism, as Patrick calls it, it can be applied to any scale. So that's something I found very fascinating as well. So we work at the building scale, we work also at the facade scale, and we work at the interior scale, at the product scale, at the, you know, like any scale from jewelry or shoes to like big buildings or master plans. So it can literally be applied to everything. And it's just a way of thinking in terms of steps and in terms of understanding topology and geometry that it's just like it's a way to understanding your brief, translate that into parameters, identifying features and moments of the project, and then exploding that and emphasizing certain moments over other ones. So you create these kind of fields of data that makes the geometry and all your patterns flow naturally in the building. Oh, that's the slide. I thought it was there before, my bad. Okay, so this is a little bit about the structure at Zaha, or the way I see it. Of course, I think very important to know that everyone at Zaha had a very different experience. So I'm gonna tell you my experience, other people will have other experience. So as I said, I work from here to here. So I do all these 3 parts. I start in Maya. Sometimes, you know, I can start in Grasshopper and then move to Maya. So I prepare something for Maya. And then from here, I move to Rhino and Grasshopper and Rhino and Grasshopper always. So in this process here, I bring stuff to Revit, but basically I stayed within these 3. We have a lot of like different clusters. So, you know, we have code, we have an interiors team, there's a VR team, there's a BIM team. So there are like different teams. And in general, like we work a lot across different projects to be able to bring all the expertise together. Yeah. So like that part, you won't see me doing in a webinar. Like that's not where I focus the drawing production. Unless it's more related to facade, which sometimes I do. So I will be doing, you know, mostly here 3D modeling. Okay, sorry, 1 second. I'm just gonna check here. How far you're involved in the design and concept itself? Comes the design from a whole team, and everybody can bring in their own idea. Have to bring the concept and sketching in a form. So I, like on the concept, I'm totally involved. The way it works is like each of us in the team, we present an option, like your understanding of the brief. And then based on that brief, like you will throw ideas and then you will pin up the ideas, and very democratically, like all the ideas will be exposed to the director, and the director or Patrick himself, depending on the case, will take the direction, and then we all take that direction. I'll keep exploring. So let's say there are like 5 designs, they won, they pick 2 of them, throw 3 ideas away, and then you have a new brief. So they already know like a bit more the direction because they pick 2 of them. So you keep pushing in that direction. So out of these 2, you branch out, and then you have like 2A, 2B, and 3A, 3B, let's say. So you have 4 options coming from 2 options that were selected before. And then that way we keep like kind of chopping branches left and right. until we get to the final one. Or sometimes it works a bit more in parallel, depends. Sometimes it might be that someone is working on a facade and someone is working on massing, and then you know that the workflow will connect in certain way. Okay. So Zaha project clusters and Zaha clusters. I'm not sure what you mean. Oh, okay. So there are like maybe that's not explaining the best words here, but basically, okay. Yeah, I'm gonna have to cut a bit short the questions because I think like otherwise we won't have time to cover all I want to cover in the webinar. But I'm happy to answer questions. You know, like in other webinars or Instagram or anything. You have my Instagram account at the beginning of the presentation. You can ask me questions there as well. So Zaha projects, what I mean is like we do have like let's say like project leads. So those are the project architects for each of the projects, and they are fully responsible for each project. And then you have a Zaha cluster or Zaha design cluster, which is a team that only does competitions. So they do concepts very quickly, but without getting in depth into the project. So they throw ideas on the table. That being said, like I don't know, my team, for instance, we don't work that much with Zaha cluster. I've been working in teams that work more with Zaha cluster and teams that don't work with the Zaha design cluster. So like it depends. Each project it has a different workflow, I must say. But yeah, this is basically the project-based teams, and then this is a cluster that jumps into different concepts to help out delivering concept very quickly. Hope that answers the question. Okay, I can't show much about my work at Zaha, unfortunately. I can only show things that have been published. So this is a project I worked for 3 years. I've been working since the beginning. So I work on the facade, I work on the interiors, and I work on the landscape. This is a project in Malta. We finalized a structure already of the entire project. We're now installing the facade. So I work on facade from concept to tender package. Here I did do drawings as well, of course. I had to do from, you know, the initial concepts to rationalizing geometry to later on detailing. And then what is important is to understand that, you know, these spaces, so two of the spaces I work on, that's the rooftop here on the top, and then this is the twist here. So where we have the lobby. So these spaces change like a million times over the course of the project. So it's very important that you have the automation and then the design control to be able to amend things back and forth as the consultants need. You know, like they give you different inputs and you know, there are like different conditions that, you know, like here, for instance, we add like 3 levels even after building the foundation. So that meant that the structure had to grow. And then we have to start adding like new splits, like increasing the size of the columns, increasing the size of the reinforcements. And there's a lot of things to take into consideration. So you do your first concept, might be like that, but then until you actually deliver it, like there's a lot of back and forth. So that's all you need to understand from here. That's another project. This is Nipro. So this, in this case, was a collaboration with Zaha Code. So Zaha Code is the research department led by Sergio Bouchan. And in this case, they work on the outer cells. I personally work on the interiors. So in, you know, like you start talking about design language, you start talking about the brief, how we understand the brief, and then we come up with like concepts that works in both spaces. This is another project, in this case, collaboration with Zaha cluster, the design cluster. So in this case, like they work out like a lot of the massing, and then I later on work on facade and structure for this. It's another competition. And then this, in this case, I think here we did collaborate with Chaga Cluster as well. Myself, I was working on the facade for this building, and that facade, I think that that's when I kind of got started on this idea of mapping. And I have this little diagram here to explain how it works. And I'll be showing a bit of like, this workflow to some other design. So basically we have modules, we have a Maya geometry, we create a topology to subdivide this geometry, and then we map these modules onto this following certain data field. I hope that's clear. You will see that this is something I use quite often when teaching. So this is some webinar I did a couple of years ago with Simorphin. So we were exploring like different modules, and then we just kind of like map it onto a quick geometry I prepared. This is from some other webinar. In this case, was done like all in Maya, different workflow. But you see like this workflow can be applied basically very easily to facades. This workflow can be also applied to shells and to this kind of like column scapes. So in this case, you have also like geometry, and then your mapping modules. The modules are columns, and then you have like a pattern applied to them. It can also be used for, so this is what I call morphing. Well, many people call morphing. Mike himself, he's developed this plugin, Pufferfish, and that's the one we're going to be using here for the webinar. Since at Saha, let's say like I do it differently because we have our own bespoke scripts, both in Maya and Grasshopper. But for teaching, this tool is available and it's free. Mike kindly developed it for all of us, so let's make use of it. So for the teaching, I'll be always using Pufferfish for this, or the Maya default plane shaping. So this is done. Also the same idea, you always have a field condition between something solid, something open, or between two conditions. In this case, it's more about mapping modules rather than pattern making. And then some other ideas I've been exploring lately is the idea of discrete elements. So how to distribute elements in a space following certain rules, which is something I'll be also considering for the master. Okay, so master itself, that's our master. Mike already explained. This is my section along with Radu. And I'm just going to explain quickly like a few ideas that, basically we're going to start covering here, and I'll go in depth for the master. So first concept is architectural geometry. I think this is like, for me, it's the most important concept when it comes to being able to think and design geometries like Zaha. So it is understanding like, the low poly modeling and the topology of each of these constructions. And you will see like how easy it is to model some of these elements once you understand how they are made. Another part it's of the research I'm developing is discrete architecture. So I guess this is inspired by a lot of the work done by pioneers, but also by the BPRO with Gilles Retsin and Manu, and some of the latest work by Zaha Core on voxelized systems. So basically, like it's idea of like working with units and then being able to map these units. So this applied to, like value engineering your design. So if you have like a complex module, but then you can repeat it many times, you can make the cost much cheaper, and therefore most likely will get built. If you're telling me that you're going to have all these components and each of them is going to be different, the cost is going to start increasing a lot, and most likely it won't get built. Like no one will want to pay for that. So it's about like, that process of rationalizing but trying to understand already from the beginning. It's a bit more like bottom-up in the sense that you start from the component and then you create an architecture from that. So that's what's happening here, right? It's like every single module is the same, but then if you distribute it in a certain interesting way, you can still have architectural qualities. But we'll have a longer discussion about it when it comes to the master. And then the last topic is digital ornamentation. So taking these inspirations that I presented at the beginning, we will try to see how we can achieve this digital craftsmanship, like this like craftsmanship 2.0, where we are able to create as much detail as we want, not with labor, but with machines. So I think that's another topic I'm very interested in, and I would like to bring it as part of the master. Maybe it's some digital fabrication topic coming on top of this. I need to see, like, you know, what's going to be the scope for the master, and then we'll see. But like these topics, I think for sure it will be part of all the webinars I'll be preparing with Design Morphine towards the master and the master itself. So 2 basic workflows that I'll be presenting today. So this is, like, for me, the most important one. So it's understanding that, you know, this petal-like column, it can be defined with very small amount of vertices, being further subdivided, get into the topology you want, apply a data field. Data field means a set of values between 0 and 1 that then you can inform with any pattern that you want. So basically here, wherever we have a white area, we'll have a pattern completely solid. The openings will be closed. And when the values are black or closer to 1, then we'll have each of these cells open to create openings. Okay. Second one is mapping. So here explaining the concept I showed before. So we have like a component, and then we have like a low poly kind of base geometry. We get to some topology. So by topology, I mean a set of vertices that are interconnected in a certain sequence. So based on that sequence of connections in between vertices, then we can map these modules onto these cells in here. So we'll be using that as well. And the 3 sketches I'm going to be introducing today is this one. I think that many people were interested in this one. So basically we'll have these 4 steps. I did this little diagram for you guys to understand, but I'll explain everything in detail. So before this, we're going to have an introduction to Maya, an introduction to Grasshopper, and then we'll jump into this. Okay. So we'll have a little break and then we'll jump. So base topology, low poly detailing, high poly, creating pattern, bang, rendering. Second sketch, it's we'll have to work a bit more with the unit. So we'll create a lot of detail with the unit. We'll get there, and then arranging this component, we'll just do it in a very simple way in Maya. But in other webinars in the future, I wanna also explain some more interesting ways of distributing components within Maya itself, or some other workflows I found in Grasshopper lately. And then this, I think it's very important also. So we have also a module, and in this case, we're going to be using Grasshopper for that. We'll shape something quickly in Maya, and then based on these surfaces here. So very important that you can understand this step as NURBS or high polygon mesh modeling. I'll explain the difference later. But basically, once we have these strips here, we'll be mapping these modules here onto that. And that's how we're going to get here. Okay. So this is all in terms of presentation. I'm going to close here. I'm going to open my my Zoom, if I can. I'm going to see some quick questions. So with the master program, I assume no project concept. Yes. Oh, I think this one is done. Thank you for the workshop. I was wondering about the first steps in getting involved in research and what advice you will give to someone who is starting out as an emerging professional. I think this, I mean, not because I'm teaching them, but I think these webinars are a fantastic way of getting started, getting a little taste about, you know, every different workflow out there, and then see where your interest is. I didn't have that opportunity when I started. I basically started reading books and in forums. So I think it's magnific. It's amazing that you guys have the opportunity to do these quick webinars. How far are you involved in the design concept itself? Comes the design from a whole team and everybody can bring its own ideas, or do you have to bring concepts and sketches in a form? So there is no discussion of ideas. You model, you finish your model, you have 1 day. So everyone has 1 day. At the end of the day, you pin up your ideas, and then you know, the best one continues. So it's the survival of the fittest. How do you combine complicated problems in relation of area with the concept, hospitals, for example? So, well, I mean, every project is different. I don't think there's a kind of magic formula here. I think we identify what's the most striking thing to do and what's the answer that the client might be expecting or might not be expecting. So we might come with a surprise technique, and then we address each project differently. Very important is to understand that, you know, I think Saha Legacy is it's based on the idea that if we've done it before, if we've seen it before, we don't do it anymore. So that's what she will always say, and I think it's still part of the spirit in the office. Could you just recommend us some books? Well, I don't know, for Grasshopper, I think the ones from Arturo Tedeschi, for sure. And for Maya, unfortunately, there is no good documentation out there. That's one of the reasons why I started doing these webinars. How do you optimize Maya geometry in Grasshopper? Yeah, we'll explain that later. Is working Saha friendly environment, also in terms of pinners, design gets chosen, the brief and continues to be developed in self-creation of the person who created the original form. So I think it's, you know, like it's not like they give you a medal, but like everyone gets credit for what they do. So I think it's very good in that sense. Okay, let's get started. So I'm gonna stop sharing. I'm gonna stop sharing the screen, and I'm gonna share my other screen, and I'm gonna switch off the camera so there is no lagging issues with Maya. I'll be here, I'll be talking, so I'm not going anywhere. Just give me like 2 minutes, guys, and I'll be right back to start with Maya. Please get your Maya files started. Hello, guys. Okay, I hope it's all good. I'm going to be starting I'm going to be showing Maya. We're going to start from the very beginning. And yeah, just keep dropping questions there and I'll try to go through them, okay? Okay. Okay, let's see. I think the camera I can put the camera probably for this one. I guess it's nice to see someone on the other side. But if I see that it's a bit lagging, I just stop it. We have like quite a big number of attendees for this webinar, so we We need to make sure that we don't have any lagging issues. So let's start here. Can you guys see the screen?
Yeah, we see it.
Okay, thank you, Mike. Okay, so this is the file I share with you. I think Mike sent it already. So that's going to be our introduction. I'm going to explain a little bit of the interface, and then I wanted to split in these three parts because for me it's the most important thing to understand from Maya. That's my favorite part. Patterns can be done here or in Grasshopper. This can be done here or in Grasshopper. Okay, so I hope that's clear. So let's start from the very beginning. I know that many of you have done webinars with me before, but I think it is important that everyone understands a little bit of the interface for those who are new. So we're going to start a little bit beginners here, and then we'll jump to more detailed things. Okay, so okay, let me see. Okay, we're ready. So before we start, I think the most important thing is to understand a little bit the menus. Okay. Okay, actually, right. Okay, you can still see the screen. Okay, that's great. Okay, so just stop my video just in case there's problems with that. Okay, so we start here. Before we start, settings. So in terms of settings, we're gonna go here, Windows, Preference, and go to Preference. And then we're gonna make sure that everyone has the same settings. So we're gonna have the Z-axis pointing up because like basically like Y is understood as the Z axis for some other industries. For me as an architect, I need to understand as the Z going up. The units in Maya doesn't really matter. They're just units. And then basically what I do is like when I bring it to Rhino, I scale it down or scale it up by 10 or by 100, whatever I need. Then another important thing is to have the undo increase the number to something like 200. So I can always go like Control Z, Control Z, Control Z, and up to 200 times. I think 200 I found a good ratio. And then the other one is to enable the autosave. So I have my autosave here in one folder, and Maya is quite a trashy software, and especially when you are doing like heavy geometries, you want to have that one on so you don't lose your geometry. And I have it like saving every 10 minutes. Okay, so that's the first thing. Another important thing is to explain a little bit like how we work in Maya. So there are like a lot of menus in Maya. Maya is a very interesting and complex software that can be applied for many different things. For my webinar, I'll be covering mostly the modeling menu here. So if you see, when I change to any of the other menus, all the menus here on the top will change. We're going to be focusing mostly in modeling. So that's why I'm just telling you like we're not going to be covering those ones. So that's one thing. So within modeling, we have all these little menus or sub-menus here. We are not going to be working with that. That's one way of working, but that will be a slow way of modeling. I'm going to be working mostly with the shelves. So the shelves are these ones here, where you can customize, each of them and create new ones if you want. So you can create new ones with your own scripts. So let's say if I created one new here, I can create another one. We can just call it webinar. And then I can go to one of the menus and say, let's say delete by type, this one. I'm going to do Control Shift right click. And that's how I create new icons here. So each of the menus, I can bring it here as a kind of quick access for me. And then the other way, and my favorite, is to, spacebar, right? Or with the keyboard, like just with typing a few keys, you will have access to everything. Okay, so I think that's fine. Let's create like one shape so we can explain more things, okay? So we're gonna start creating one cube. For that, we have right now 2 ways of doing it. One is here, create polygon modeling cube. I think that's the easiest way. I like to always have the interactive creation on. So when I click on the cube, I can just drag here very easily. Yeah, drag and drag. So that's my cube. I'm gonna switch on the edge, the wireframe visibility, so we can see the edges. And then you guys might not have that menu here. So that menu is located here, is the outliner. So that's basically how we work with layers in Maya. The layers concept is a bit confusing. So here the outliner basically displays everything in your scene. You also have here something called layers, which I only use when I need to hide or block something. So let's say this one, I can add it to a layer and I can, keep it transparent, or I can keep it as a lock object, which it can be useful in some cases if you want to model and snap onto here or something like that. Otherwise, I always use here my layers. So let's say if I want to make another copy, I do Control D. I'm going to press W and I'm going to drag it here. And then as you see, we have 2 elements here. If I press Control G, I create a group. So G for group, and we make a group. And then I can do Control D and make another one. And as you see in my group, I have 3 cubes now. If I want to bring this one out of the group, I can just drag it outside very easily. And I can drag it back in. Okay, so that's how we work with layers. Okay, so let's explain a little bit about our channel box and the side menus that we have here. So I explained the outliner already. In here we have the channel box. So basically, if this is my initial cube, in the channel box it says where it's located. Okay, so I can type it if I want to locate it somewhere in particular. We do have also parameters. So Maya is super interesting to know that Maya was a parametric software even before Grasshopper was out there, right? So notice that I can take my element here and I can, let's say, I can move this face here and I still, or I can take these elements and rotate them, so do a little twist, and I can still come back here and say, okay, actually the height needs to be higher than what I had before. Okay, I've got a pop-up showing. Okay, when I open Maya intro file provided, why can I not left mouse and rotate? I can toggle up, down, but not rotate left and right. So, sorry. So if I press, so how to orbit and move things around here? It's always with Alt. So Alt and right click button of the mouse, you zoom in and out. With the middle mouse button, you drag, and with the left one, you orbit. Very straightforward. If you want to go to another view, you press spacebar and you go to any of the other views. More things about like interface. You can have here the different modes. We're going to be always, I think, on the shaded mode. And then as playing, so these are more like for visualization. And then this is for like using the lights. We'll show that later, okay? Let's keep going here. I think I answered this one. Okay. So about Maxwell mental ray nodes, I don't think you need to install that to work. So how to hide the outliner? So if you want to hide an element, so let's say I have a copy of this and do Control D. If I want to hide it, I press H. And another very cool one is to do Control 1 to isolate, and Control 1 again to desisolate. Okay, so I'm gonna delete this one for now. Okay, so how to twist the thing again? I'm gonna do it many times. So let's start again. So I'm gonna start now from here. I'm gonna create a cube. I'm gonna drag and drag. And then here, the most important thing for now is to understand that it's a fully parametric model and it's a non-destructive workflow. So whatever we do, we all have, like, we will keep the history here. So, you know, like in the office often, like I try to have like clean models that I can keep my history there, so to modify anything. And if I can't keep my history, what I do is Control D and I make a copy on the side. So I can always reverse back to my previous model. So let's say like here, I will start from a cube and then I'm gonna create my vertices. I'm gonna type my vertices and I'm gonna rotate here. And then I have the next step that, you know, maybe is to move some of them up, whatever, we will see, yeah? And then I just keep all the steps here so I can always reverse back. Okay, so that's my channel box where I kind of get all my parameters in there. Then there is the modeling one where we have some quick access tools. We have the attribute editor with more options for each of the menus. And this human thing, I don't use it. And the important one also, this one, the tool settings. So the tool settings, what do I use it for? I use it for moving with accuracy. So if you want to be accurate when you're moving, I can do here, let's say step snap. And I can say I want to move in units, so by 2 units. So this is always moving by 2 units. Okay. So this is how you move, like, you know, in steps rather than freely. But you need to understand that Maya, it's not a software where you want to be like, you know, it's not, it's more like you are sketching. It's like almost if you were sketching by hand. So it's where you get your concept. And once you have your concept, then you can be rational somewhere else. Okay, so let's keep going here. How do I do things? You know, I'm not accessing the menus. I don't access the shelves. Why do we use Maya rather than other software? That's all related to what I'm going to explain now. So how can I move in between? So basically, we have a polygon-based modeling software. That means that we can quickly access the edges, sorry, the vertices, or the edges, or the faces. To do that, you just right-click, and then you get to one of these submenus. So face, I move it, edge, I move it, or vertex, I move it. Another very cool thing is like if you press Shift and right-click, you actually get only the submenus that are connected to the geometry that you've selected. Meaning that if I want to be, if I'm on vertex mode, I'm going to select, let's say, this vertex. And if I press Shift right-click, it's only giving me things that concern, like giving me options that concerns the vertices. So I can chamfer my vertex, or I can, I don't know, multicut, I can extrude vertex. I have this option, but it's only things that are connected to the vertex itself. It doesn't give me any other submenu. So I don't need to go there and start like finding what is that I want. So let's say like if I go to face, I can press Shift right-click, and I can extrude my face. And then here it's giving me some other options, which is, you know, what's the thickness, the local height, the offset, etc. So I can say like offset by 0.4, or maybe, I mean, depends on the scale. So by 3, and then I'm just going to drag it here. very easily. Okay. I can also get to, like an edge. And then if I press Shift right click, I can, for instance, bevel it. And then I can say, segments, no segments. So I'm going to say 0. So I bevel that one. So it's very easy to access the menus within just, without looking at moving your mouse. You basically press either spacebar, right click, Shift right click. And another thing I use a lot is like, so you can also do select the face and control right click to convert your selection from face to something else. So I can convert it to vertices, for instance. So I use these three things a lot. So basically I don't move my mouse from the center of the screen. So I become very fast. Yeah. Okay, so that's it. And I'm going to create another shape. Let's say like a little cylinder. So I move it there, and then I say, okay, so that's not exactly what I want. So I'm gonna go radius 5, height 20, subdivision 6. Let's say like I'm happier with this. So I'm gonna select some of my faces. This is just to practice, yeah? So I can delete those faces. I can select these ones here, delete those ones, select this one, and then I can say, by the way, there's this concept of loops. So if I don't want to select each of them with the Shift and left click, I can double click and it selects everything that is in a continuous loop. Okay, that becomes very handy. You will see later on. So I can select all of them and extrude the edge and say like -15. Sorry, I'm here. -5. And then I can fill that whole thing. Okay. We can select another one here, multicast, and we could do levels like this, but we will see later on how to do that. So how to move, let's say like how to move, rotate, and scale. So that's very straightforward as well. So Q is for selecting. Sorry, Q is for selecting, W is to move, E is to rotate, and R is to scale. Okay, and then you just drag like each of them depending in which direction you want to scale. So that can apply to the entire object, or as I was doing before. So let's delete this one. I'm gonna delete, and I'm gonna insert 4 loops. 4 loops here. So I select this one, so just one edge, and I'm going to. Well, actually, what we can do, we don't need 4 loops. We just need. I'm just gonna select all these vertices, which is exactly what I did before. And we're gonna rotate it by 90 degrees. So that's how I twist a tower. You see how quick? We just need to select the geometry that we want, and we twist it directly from here. If we want to twist with control, I have the step snap here selected. So this is always by 30 degrees. So now what that means is like, I can have control over that. So I can create this twist, these loops here, and select this entire loop, twist by 30 degrees, select this one, twist by 60, select that one, another 30, another 30, and then I select these geometries, and another 30. So I could do like a twist tower very quickly. Yeah. I get the menu when pressing spacebar. I don't get the menu when I press the spacebar. Okay. So the menu when you press the spacebar, this mesh, edit mesh tools is exactly the same thing that you have here. But basically, like you remember where things are, so you don't need to move your mouse all the way up there. It looks like a small thing, but when you have to repeat operations many times, that becomes super, super handy. Okay, so I want to get started with some of the, so I think that's that's it for like interface. And I want to get started with some of the geometries that you have in your little intro. So I'm running a bit late in general, but that's fine. I think like the beginning is always lower than you predict. So we're gonna create a little plane here, okay? And I'm gonna go to my channel box and I'm gonna say this is gonna be 10 by 10, yeah? I'm gonna zoom in here. So to focus, I just press F, okay? And I'm gonna say also, this is gonna be 2 by 2, okay? Okay, hope like everyone, let me see the questions. Okay, where can I access the tool settings? So the tool settings is this little guy here, that one, the hammer. Which hammer? This hammer, the hammer with the 3 dots. That's where you have it. So what I did is like I just drag it here. So repeat how to create a plane. Yeah. Okay. So I'm going to be repeating everything million times. So don't worry, guys. You will all understand the process. So I create a plane from there, or you can create a plane from here. It's the same. So here is where you have your basic geometries. Yeah. So I'm going to create my plane, and what I want is and just to type width and height 10 by 10 and 2 by 2 for the subdivisions. Okay, so that's the very beginning, because I want to explain. I did Control D to create a copy, and I want to explain, you know, what the CATMUL algorithm does. So basically, I want you guys to take these 4 vertices, shift, right click, and chamfer vertex. Okay, you will get familiar with all of them. And then here is where we control the distance. So 0.25 seems about right for me. I'm going to select these faces, delete them, and then I'm going to select all the vertices that haven't been chamfered, press W and move them up. Just like, you know, by eye. Doesn't need to be specific distance. So what is important here, and the intention of this little sketch, I'm gonna bring something here for you guys to see what I mean. So let me see, display. Okay, so I think, okay, so Mike just told me that you might have a different Maya. So I think here is where you have the interactive creation. You need to have it on. If not, it's fine. You create a plane and, you know, I'm gonna remove it and then have this one here, create a plane. It will create a plane somewhere here. And it's gonna be a bit more annoying, but you can just do the same, 2 by 2, 10 by 10, and it should be exactly the same plane. Then you can rotate it, and you are in the same place than I am right now. Okay, so yeah, so I have here my little shell, and see that I was here. Sorry, heads up display. I want you guys to go here, heads up display, and say poly count. So basically, what it does, it tells you, you know, like how many vertices, edges, and faces you have in each geometry. So in this geometry, in particular, that's the entire scene. In this geometry, I have like 13 vertices. And see that within 13 vertices, right now I'm in low poly mode. If I press number 3 for CATMUL algorithm, I get already a little shell that basically it's, you know, a CATMUL algorithm is an algorithm to subdivide a mesh to kind of smooth it. So you can read more in Wikipedia. I'm not going to get into details, but basically it's an algorithm based on a mathematician to subdivide geometry, and it's used a lot in low poly modeling. So what is cool in Maya for me is like I can press 1 and 3, and just by pressing 3, I see how the final geometry will be like. So that's still kind of easy to model in Rhino. Yeah, I think everyone can model that in Rhino. I will see like how some of the geometry we're going to be doing, like it will be quite tricky to think about it in Rhino. And then what is cool about it is like, you know, I have very few vertices. So basically now I can just select some of them. So let's say like I'm going to select these ones. And by scaling 4 of these vertices, I'm already changing the entire geometry. In Rhino, you will have to change each of the curves, and like create the surfaces in between would be a bit messy. You know, like very easy to get geometries down here. And another thing is like you see that segmented edge. So basically we can smooth that one out by, so if I press, I'm in 3 mode and I'm gonna press page up, 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 up. So that's are the 4 different levels of subdivision for the cat mode algorithm. So we wanna see it in 4 always to have it perfectly smooth, okay? And then if you want to freeze this geometry, let's say like I'm happy with that, what I'm gonna do is to make another copy of this one, and I'm gonna say modify, convert, smooth mesh preview to polygons. And that now, if I press 1, it doesn't move, yeah? Which is actually the geometry that we can use for, I can export this, you will see. I can export this as a, let's call it test, as an OBJ, and then I can come to Rhino, and I can import this test. And we will have here our little geometry, yeah? Okay, I think that's clear. So we're gonna do a few of them and you will see, but basically before you export, you always wanna smooth it out. And you wanna have a low poly version, this one, where we only have 13 vertices, and a high poly version where we convert it to 1300 vertices, okay? So let's do another of these ones. So another, you know, copy of this to practice. I'm gonna make a copy here. So you see like how I always make a little catalog out of what I'm doing. I think that's very important for you guys to keep your files organized. Okay, see, there's so many questions. I have Maya 2020, and when I create a primitive, they are not editable. They are, I mean, unfortunately, Maya, it's a bit stupid. So every version, they change it a little bit. So when you create a primitive, they are not editable. They should be. So you create a polygon, so let's say cube, and then here you should be able to change it always in whatever version. I think I've tried many of the versions. Okay, so you should have it here in the channel box. Was it freeze transformation? What is freeze transformation? I guess that's the question. So I'll explain that later as part of the workshop. To quickly set the pivot center to the center like in Rhino. Okay, so the pivot center, actually that's an important one. I didn't explain that. So in terms of pivot, like the pivot, you can press D, and then when you press D and you have that highlight, if you press V for what? For Valencia, you can move to a vertex. Like, you know, you can always snap to another vertex. So that's how you move the pivot. That's important. Okay. So if you want to always move, let's say, I want to, let's say like how I will do, if I want to move this one up and then I want to put this one at the same height, I press V and I drag this one here. Now, if I want to, let's say, make another copy of this one and mirror it, so I'm going to mirror this. So I'm going to say -1, so -1 in this direction. And I want to snap this to here. So I can do D, move it there, and B again to move it down there. Okay, so that's how I will be snapping things together. So notice that when I press 3, these things are not yet connected. So in order to connect it, we're going to have to combine them and then select these vertices and do shift right click, merge vertices. So now this is part of one single geometry. Okay, so this geometry, now we can continue. Let's say it could be some shell. Okay, we can use that geometry later for something else. Okay, wow, it's a lot of questions. How to manipulate the shape again. Okay, let's do another one of these. So hopefully that solves some of the questions. Okay, so I'm gonna make another copy here. And I'm gonna chamfer, so I prepare many of them so that I can resolve questions with different examples. So for those of you who understand the exercise from the beginning, it doesn't get too repetitive. Okay, so I did the same. So sorry, I didn't explain the commands. Maya, it's a bit tricky at the beginning to get all the commands, but you know, eventually you will get it. So I'm gonna do polygon, plane, on my plane. I don't have the interactive tool on, so I'm gonna put it back on here, and I'm gonna create it from here. In this case, plane. I'm gonna go to my channel box and say 10 by 10, 2 by 2. Okay, once I have it here, I'm gonna do right click, go to my vertices, and select these 3. Right click, shift right click, chamfer vertex, right click, go to face mode, select with shift all the faces and delete them. So is there a shortcut to quickly set the pivot center to selection like in Rhino? So you can press F to zoom in the selection. That's maybe what you mean. And then the other one is like, you know, if your, let's say your pivot move somewhere, let's say like in pivot mode and move somewhere there, and like, oh, it's not in the center anymore. You can go modify a center pivot. So it goes back to the center. How to manipulate the shape again on the right side? I can see the divided. Okay, so I think like about the subdivisions, you will see now with this new example. And yeah, it's about high poly, a lot of questions. So I think that's fine. I'm gonna get there. So I'm gonna do Control D and make a copy here. We're gonna move the vertices that I don't have selected. So I don't have chamfer. So I move these ones and check this one. I quite like this one. It's a very nice low poly. And think, you know, like if you have to model this in Rhino, it's already a little bit of a pain in the ass. You know, have to model it probably in 4 patches of surfaces. So that's super, super easy to control here in Maya. And it's all thanks to the cat mode algorithm. So I think some of you were asking like how to control the smoothness of it. So it's page up and page down. So I go page down. So that's the first level, second level, third level, and fourth level. You can also access that in case you don't see it. You can go to the attribute editor and then smooth mesh. And here, subdivision level, you can change it from here. So I'm going to say 4. That's the smoothest it gets. Okay, so I can go here and start, shaping my geometry as much as I want. Okay, so once you have that, the next question some people had is like how to create all the subdivisions so that, because let me show you, like you see it here smooth, but when I do file export, and I'm gonna say test02, when I export that to Rhino, you're gonna be like, oh, where is my, nice fancy geometry? It all became like boring. It's the same geometry. This is like a low poly version of it. And then the high poly version, no, actually I had the camera off. Okay. I'm gonna have it on for now. I think it's fine. It doesn't seem to be very laggy. Okay. So yeah, like okay, let me see. Okay, there you go. Okay, so here we are. So if we want to actually export to Rhino, what we're going to be doing is to do modify, convert to smooth mesh preview. Yeah. And if you are in 4 mode, like, preview division 4, that's what you get. If you are, let's say, in mode 2, so you still see the edges. Yeah, it is like segmented. If I convert it to smooth, that's what I get. So we can actually like smooth it to any level of subdivision of cut mode. Okay, cool. So that's the second one. I'm thinking, what's the time? 5:30. Okay, so I think like we need to speed it up a little bit. So let's take this one, and I'm just gonna do like to explain this. I'm gonna show you. So let's say like I'm gonna do Control D, and I'm gonna make a copy of this -1. So it's not here, but -1 in this case. And then with D and D, we'll snap it here. So I'm gonna show you again how to combine, because that's very important. And then if we combine these two, when I press 3, you see that this is not yet merged. So we need to right click, go to vertex mode, and shift right click, merge everything together. So this is like how you can, like you can get like a little pavilion very, very quickly. And I think like, I don't know, like this stuff in Rhino, I'm not saying you cannot model it, but like it just takes a while to model these things. 1 second. Yeah, so I think like it's just for a good workflow and for the best interest of everyone, I'm just gonna speed up a little bit, and we all gonna have the videos, so you can see the videos back and forth, because unfortunately, like, everyone is not at the same level, and I think there are some of the questions that I'm just gonna be repeating over and over. So yeah, I mean, sorry, as I was explaining, like model this little guy, but you see like how fast it is. Like, again, this is what, like 22 vertices, which is so easy to keep modeling. And let's say now the consultants say, oh, actually, like we need the footings to be spread like a bit wider than what you have. So I just come here and boom, boom. Still have the same topology. So I think that's what Maya is very good at. Like, topology is like, the sequence of vertices connected the same way. So I can still manipulate things, and my Grasshopper or my Maya patterns will still follow the same logic. So as long as you keep topology in order, as long as you keep the same connections, you keep moving things around and nothing is going to change. So let's say like you have this one, yeah? And I just want to add one more level of detail, which basically is going to be like to extrude this one. So if I press 1 here, I'm going to go back to the questions, guys. I can see like they're populating, but just need to move on a little bit and then I'll get back to the question. So I'm going to offset by 1 unit here. I think 1 unit maybe is too much. So notice now that I can always get back here, okay? And I can go to my extrude parameters in the channel box, and I can say here, where are you? I think it's this one. No, sorry. I think maybe this one, 0.5, yeah, here. So I can just change it back to 0.5. Actually, like there is a way to, yeah, here. So if you click on the name of the parameter and you press the middle mouse button, you drag to the left, you go minus, you go to the right, and you go positive. And then you can just eyeball it and see, you know, how much you want it for now. And then we're gonna, you know, basically what I do is like I take all these parameters and I make a Grasshopper model that works in a similar way. The problem I see in Grasshopper is like for those that start modeling Grasshopper, the concept, you don't know what you want to get, and then you're already bringing a lot of information. So then it's constraining what you can actually finally achieve. Whereas here in Maya, I'm just playing with things very quickly, boom, 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 boom. I get many different options. And once I know, then I can optimize and gain control in Grasshopper. Okay, so we have this little guy, yeah? So now, of course, we have double the amount of vertices. I press 3, and you know, like it's not as sharp as I wanted because I want to see a little edge. So for that, we're going to introduce another concept, which is the creases. So I'm going to select that face and I'm going to shift, double click, and get the entire loop. Okay, so I'm going to repeat it because I know it's going to be a lot of questions about it. Select one face. Okay, I'm going to go in low poly mode and press shift, double click with the left button of the mouse, and I get the entire loop. And now I press control, right click, and I'm going to convert this to edge perimeter here. And now, once I have these two loops of edges selected, I'm going to press space. I'm going to go to edit mesh. No, here to mesh tools, and I'm going to say crease. And I'm going to press the middle mouse button and I'm going to drag all the way to the right. And that's going to give us our sharp edge. So basically, what is a crease? One thing we can do that I often do is to bring the crease here to my shelves. So I'm going to go here to crease and I'm going to press Control Shift right click. So I have it there. It's very much faster to access. So I can uncrease and crease back just by dragging left and right. So what a crease does is very important for those of you that are also familiar with Grasshopper and wants to understand how this is going to connect back to Grasshopper later on. What the crease does is basically separating, detaching this geometry from the next geometry from the next geometry. So we're like splitting basically, just visually when we're creasing, and later on, that is very fast, yeah? So, you know, select, boom. And then I want to increase this one. Let's say I want to increase this one. I can increase this one. And then I start exploring, you know, oh, what happened if I crease these two now? And you're going to start getting, you know, like all sort of different patterns, yeah? Like, I don't know, I can select these two here and then start, we can, oh, maybe, you know, I'm going to get a little edge with material and this is going to come down here. We can start exploring like how the connection between the creases will work like. I never tried this actually, but it could be cool. we can test it. So we can move these ones in and maybe move them back there. And we can have this geometry here, you know, like that, maybe. I don't know, that could be a feature, maybe. So now we could, let's say, move this one down. But you see the play with the creases, like what you do, like you start dividing the parts of the geometry. The simplest thing, which is what I want to address here, because that's not the design exercise, this is more like for introducing Maya. I'm going to extrude once again. I'm going to say 0.4. I think that was the number. We like it. Select the faces, control right click, convert to edge perimeter, and then go to my crease tool and crease. Then I'm going to take this one. I'm going to take that one and crease again. And then now that we have the crease selected, what I can do is, like, let's say, select this one and that one, and maybe, you know, start playing a little bit with how we're showing that edge. Okay, that's wrong. So need to select that one. This is like, it's very nice to scale, to move things with symmetry. I think it always works. So I don't know, maybe we want to show it like that. Yeah, seems like more right to do it this way. So I'm going to select these ones and move it down there. Maybe I'll take this one and that one, move it down. Yeah, so we can, you know, very quickly play with this. Imagine in Rhino, like it will be a bit of a pain, or even in Grasshopper, to do these things quickly. Okay, but you get the idea. Yeah, we can get a little shell very fast. Yeah, I think maybe I should do at some point some webinar about shells again. So how to change material? I right click here and I can create a new material. I'm going to create a blend to have a reflection. I go to my attribute editor. I'm going to call it black or dark, and I can just create a material here. Yeah. Okay, I think that's fine. So I think, like, I had more shells prepared, but you have them, like you have them in the, I mean, we could keep playing with shells. They're super fun to work with, but I think I want to focus a bit on showing you the patterns before we move to the design exercise. Okay, so let's take this one, yeah, as an example, or let's take something even simpler. So let's say like this is low poly modeling. I'm going to take this one, and I'm going to show you how to do quickly some of the patterns. Okay, let me go through questions, actually. Okay, I'm sorry to bother again, but I'm afraid that it's not editable and it all seems like it's just a cube and I can't access to the menu. In fact, in the outliner, my icon for the plane is different than yours, like less subdivided. Okay, Borja. It should be editable. I don't know what to tell you. The icons, they might change between versions, but the geometry should be editable. Like I've tried 2020 and it's not a problem. Yeah, I don't know, maybe like what I can tell you is like you can create it either from here or you can create it from here. Those are the two options. Okay, I think, okay, that's fine. Maybe I'll for the design exercise after this, I'll remove the camera. I think someone was saying about the lagging issue. That's fine. I'll remove it. I just thought like it would be nice for you guys to to see a face rather than a voice. How to bevel the mesh to high poly? I think that was answered. Then how do you move with snaps? So to move with snaps, so I press D always to go to snap mode. You always want to be moving things in low poly, and I press always to V. So there's other things that you can snap to, but because we are in low poly modeling, the best one is to snap to the grid or to vertices. So now I can move, I don't know, let's say I can make a copy and snap this one to the next one here. So it's D and V, I snap it here. Yeah. So please one more time the edge creasing, how to set the edge. Okay, not sure I understand that one, but I think what you want to see is how to do the creasing. So I'm gonna do the same with this one. So extrude. I'm gonna say here by 4. I'm gonna select the edge, Control and right click, convert to perimeter, and then the creasing is here in Mesh Tools, crease. And middle mouse button, drag all the way to the right. And then when you press 3, you have it there. If you see that it's like segmented, that's because of your subdivision. So as you see here, I have 4 now and it's all smooth. Okay, hope that answers the question. How you compare SAPD to Maya for this workflow? What will be the main advantages and disadvantages of each other? So SAPD, I think still I prefer polygon modeling, but SAPD, it's SAPD in Rhino 7, it's definitely going in that direction. So, I mean, SAPD basically is, that's what I do here. So if I want to convert this to NURBS, yeah, so how will I convert this to NURBS? So let's convert this one, the simple one, to NURBS. So this is a low poly version, yeah? I'm gonna make a copy here, and I can do convert to SAPD. So this is what Rhino 7 does. This is a SAPD. And then if I make another copy, I can convert this to NURBS. So it's SAPD to NURBS. And then those are surfaces in Rhino. So don't mind the green. That happens always in Rhino. But then those will be my surfaces in Rhino. So those are patches of surfaces. So SAPD is similar, but I think in low poly, you are even lower in polygons, so therefore more control. That's why I prefer low poly modeling. But I'll try to, I mean, for the master, we definitely will cover SAPD. Maybe I'll try to do something with SAPD before the masters. Okay, so more questions. Having a lot of questions. Okay, so I think this is done. Please, one more time the edge. I think that's done. Shortcut for offset mesh. For offset mesh. So I think, I mean, shortcut is you can do. So I do shift right click and extrude. I think that's quite shortcut already. So that's how you extrude, which is the offset mesh. Here it's just called extrude. How do you get the vertices to merge? I'm selecting them after I shifted them to touch, and it will merge. So I'm going to repeat it here, D and B. I'm going to make a copy, move it there. And then here I'm going to say -1. Sorry, -1 here. And I'm going to move this one there. You first need to, so maybe that's the step you were missing. You need to combine them. So for that, I go to modeling tools and combine. And then once I have them combined, so combine means that they're both one object, then I can select all my vertices and do shift right click, merge vertices, and then they will merge. Okay. Cool. Okay. Okay. So how do you move object from one vertex to another vertex snap? So I think I covered that already a few times. So if I'm in low poly mode, I'm gonna make a copy of this one. Okay, so I press D and V, so that's how it's relocated. So let's say if I press V, I can move it to the up. If I press V, I can, what's going on? Okay, press V, I can move it to any of them. Because this is a subdiv, okay. So you see, like I can sub this. So basically, you know, like from low poly, I go to NURBS, but from NURBS, I don't go back to low poly. So, you know, that's how you snap. I'm just pressing V for vertex, and that's how you snap to vertices. That's it. And if you want to change it to the center, I press D, snap to the center, and then I snap again. Okay, I hope that's clear. Okay, cool. Okay, I think all the questions are done. Okay, so we're gonna move on to the next thing, which is patterns. So this is very important, this step that I explained here about NURBS and subdivs. So here we're gonna move to patterns. Okay, so let's maybe try to keep this organized. So I'm gonna group them all there. And I'm gonna delete history to keep it control. And then these ones, I'm gonna group them. And also delete history. I can delete that one, I can delete this one, I can delete that one. And then this is the new group. Okay, so this is like, you know, intro or low poly. This is like a mesh to NURBS. I call it and then here we're gonna do something else. So I'm gonna save this one. Actually, I wasn't saving it. So let me create a folder here in the desktop. So I'm gonna copy here the location. And we're gonna call this one part one intro. Okay, so I would like to try to finish this in like 50 minutes. So we can actually catch up a little bit with time. Otherwise, I won't be able to explain everything I want to explain. And I really want to give you guys a good introduction. So let me see 1 second. Okay, so patterns, yeah, patterns. That's what I needed to do now. So patterns, you can smooth here. Yeah, I'm gonna smooth it from there, and then this is basically what we call quads. Yeah. So what can we do with quads? So with quads, let's say for instance, something we could very easily do. We select all the faces, shift right click, extrude face, keep faces together off, and then say here. You have many types of patterns that you could do. I'm just going to explain some of the basic ones, but we can explain them all. In the master, we'll get a lot of, a lot of sessions based on this, but this is like at the end of the day, a 5 hours quick tutorial. So what I do always is to follow steps so I can remember next time, or like someone else that opened the file can remember next time. So what I did is to extrude every face with each, so extrude each individual face to get that offset. And then here, I'm gonna do extrude again to get the thickness, okay? Okay, something worth explaining here, like if you see here in the inputs, I only have access to the last input. If you want to make a copy with history, so you keep the history of what I have here, I need to go here to duplicate spatial, parent, and duplicate input graph. So I say, okay, and see the difference when I move it here. I'm going to extrude again this one. It depends, like it gets heavy if you keep a history of everything, but sometimes it's worth, like in this case. So in this case, you see I have 3 inputs and here I only have the last input. So basically what this means is like I could still go back, even if I'm on the thickness already, I can still go back and say, no, this is going to be 0.3. Yeah. So I have more control in here than in there. It depends what you need. Okay, so that's fine. Easy peasy quads. So let's do something else. So we could also, let's say, what we want to do. Maybe we can do the exa kind of, or the die-grid. I think the die-grid is a good one. There are 2 different ways to get to the die-grid. One way is to select all of them, select all the vertices and chamfer them by 0.5, and you get to the die-grid. This is not a die-grid. What's happening is like they have all the vertices overlapping. If I press 1, if I press 3, this is what I get. So these 4 vertices are overlapping, and that's how I'm getting here. So that can be solved by selecting all of them and shift right click, merge vertices. So that gives me a die-grid, which I always find like, you know, a sexier topology than my classic quads. Notice there is a change in topology. So that vertex here, yeah, becomes a 5, kind of like an angle, like 5 sides polygon, which then it had like, you know, a number of implications. So that's part of your design thinking. When it comes to rationalizing, this is flowing naturally here, yeah, and then you have these kind of quads in there. So you'll have like one shape there, one surface here, one surface there. So you divide it into 4 patches and the central bit. Whereas here, it, you know, like it's slightly different. Like I think it's more difficult here to understand in terms of surface. In terms of pattern, I think it worked pretty well. So let's say like from here, maybe something we can do is to, you know, like, I don't know, here we could, we have the die grid, and then we could further like maybe poke each of them. We poke, we don't really get anything because we just want to get back to where we were. But maybe, you know, I don't know, maybe we go 0.5 or like 0.2, and we're gonna use that for something else. Like we'll have to think it through. Yeah. Another worth explaining one is the exa. So for the exa, basically we need to triangulate. So we're going to triangulate here. And then once you triangulate, you need to take all the edges, and we need to save this set. So you can create a selection set. So what is a selection set? So it means that, you know, if I don't want to select them again, let's say like I have to select a lot of things manually, this becomes very useful. In here, what we're going to use it for is like, I'm going to save that selection, and then I'm going to go to smooth, and then I'm going to recover this selection. And if I delete this selection now, I get already my hexagons. Well, it's not hexagons always because we have n-gons. So for that, to get like proper hexagons, I think we'll need to do it here. So I'm going to triangulate. So triangulate here. Once I triangulate, so this is like after this step. So that's important to understand. So I'm going to put it here. Once I triangulate, I'm going to select all my edges, and I'm going to save the selection. I'm going to smooth this out. I'm going to recover my selection, and I'm going to delete it. Okay, I mean, I don't know why this one is, well, it depends on your topology, but that's basically like how you get to hexagons here. Interesting that you get a quote here. Okay, so that's hexagons, and I don't know, maybe you can, I mean, literally like there are so many. You can also, I think another cool one that I like, it's, okay, I think it's, let me see if I remember. This is almost like a recipe. I like to say that, you know, this is procedural modeling. It's like patterns through procedural modeling. So basically here, like you have like a number of steps and it's almost like cooking. Yeah. So you do step 1, step 2, step 3, you change one ingredient, you get slightly different result, a slightly different meal. So it's almost like making a little paella. So let me see. Okay. So I want to do the kind of Arabic one. Yeah. So I strangulate. And then I think here, if you smooth, I think you triangulate first and then I have to try it and then poke. Yeah, there you go. So if you mesh, if you triangulate and poke, so basically what's happening here is like, you can try them all. They're very, very cool, all of them. But I'm just giving you a few of them. Yeah. I think those are the most useful ones. Extrude face. I'm gonna unclick that one. So, you know, here maybe what we want to do is we could delete it as a low poly version of it. Yeah. So we get a nice structure in here. Or, you know, maybe what we want to do is to put in a different color. Could be also. Let's make it red. So we go to attribute editor. Sorry. Where are you? Let's try again. Any color, blue. We're going to call it red. Maybe these ones we're gonna make it like that. I'm gonna convert back to the center of the face. Okay, so let me convert to contain faces. And then maybe I'm going to poke it once again. Okay, let's remove this one. I'm gonna poke it and I'm gonna get to, I would like to get to the centers. Yeah, you kind of need to think a little bit what's the process for each of them. But yeah, basically what I wanted to do is to, maybe what we do is to move them. So I'm gonna transform the components and move them down. Yeah, so you could have like some, I don't know, something like that. It's a bit crazy, this one, for my taste, but whatever. Yeah, something like this. Later on, what we could do is to like shape it with deformers. Okay, so we'll explain that later. So that's a little bit about patterns. And I would like also to, before we move to the introduction of Grasshopper, to explain how we do plane shaping. Okay, so for plane shaping, what I'm gonna do is to get, let's say, this one. Okay, or we can do like can do like a quick one. No, I don't want to use time for that. Maybe let's try this one here. Okay, the one we did before. Okay, let's say like here and here. Let's think about this one. I don't know, maybe you can chamfer here. We can get a column. Opa, sorry. So I'm gonna move it there, and I'm gonna have a little column. I think this one we want to move it up like that. And same with this one, move it up like that. And then I'm gonna grab that loop, and this loop, and this loop. I'm gonna make it smaller and smaller. I think with the design exercises, like we're gonna explain this perfectly. Oh, don't worry if you don't get it straight away. What I'm gonna explain now. As I said, this is not a design exercise yet. It's just like a little sketch. Maybe we'll remove these two edges. I don't like them. Okay, actually, this is gonna double my work. So let's just do it like that. Cool. Okay, so what I want to do is to have, you know, like something, a geometry. To explain my next blend shape. So blend shape, I'm going to explain it first with a plane. Okay, so basically we're going to explain it with plane and then with a geometry, and then we'll jump to Grasshopper. So I'm going to smooth this, smooth, and then we say like I think the Arabic one was a good one to explain this. So I'm going to triangulate. I'm going to make another copy here. I think here I just poke it before. Yeah, and then this one I'm going to extrude. And then I'm going to say 0. Okay, 0.002, delete. And then that's my first pattern. And now I need to create a second one with the other condition. So now we're explaining blend shaping. So we're going to have one component. Actually, even before we do that, I could explain blend shape with an object. So blend shape with an object, I think it's fine. It's fairly easy to understand. I can explain it with this object, actually. I don't need to model another one. So basically what blend shape does is like I have this object, one condition, and then I have this other object, another condition. So what we're gonna do is like I'm gonna bring this one down. And so we'll bring this one down, and then okay, no, let's do the other one. So because they both have the same topology, in order to not change the topology, what you need to understand is like you can only do Euclidean transformations, meaning that you can only do move, rotate, or scale. Okay, so let's say those are the two conditions that I want to blend in between. So I can select both of them, yeah, and I'm gonna go to deform blend shape. Okay, so now one of them is going to be purple. That's the one we're interested in. So I'm going to go here. I'm going to put 1. And basically, if I type on envelope, and I drag the middle mouse button, I can morph the geometries in between these two conditions. So I can get all the in-betweens. That's how in my presentation, for instance, you saw like there was this tower blending into two conditions. We can use that. It's very useful for something like this. So I need to have the input graph. So for that, I'm going to say duplicate Spatial. I'm going to bring it here. And in my second one, I'm going to say instead of 0.02, and make it 0.2, which makes pretty much everything solid. Yeah. And if I take this one and that one, I can say deform, blend shape. I'm going to take the purple one, that one. And then in the purple one, I'm going to put this parameter to 1 and then select here and then drag left, right. So we can get two conditions, one close, one open. Why is this very cool? Because if we make another duplicate Spatial of this, you will see now that actually Maya, we could use just a paintbrush to decide where my openings are going to be open and when they're going to be closed. We can do the same thing in Grasshopper or using attractors. Grasshopper, we have much more control, but in Maya, like for something quick, it's often very useful. So I can go here to deform, blend shape, paint weight. And then here in my, I think it's, the tool settings, I can go to replace and let me remember this one. So I need to go to, why do I have these weird colors here? Okay, yeah, this color ramp. Second, replace. Okay, 1 second. Blend shape 1, yeah, that's right. Usually I get it from here. I don't know if there's a different one. Deform, blend shape, yeah, and then I'm gonna say value 0. Okay, there you go. So basically, I'm just gonna be painting here. So with B, I can B and middle mouse button, I can control the size. So I'm gonna be painting where I want this pattern to be close. So I can just literally paint it, which is very nice. So I can do, you know, like I can do like follow, I don't know, like something by connected to furniture or my geometry. But this is a very manual way of doing it. Yeah. So we all know that in Grasshopper we could have one curve and another curve, and it will do the same. But I think like to think about your design, this is very good too. Once you have like the main fill, the main blacks, what you can do is like you can click here and smooth it, and then flat, and basically you get the transitions. So you get the in-betweens. And I can always go back here, paint a bit more. We use this tool a lot. I think for a quick sketch, very useful tool. And then we get our patterns like that. So this is blend shape, and this is the beginning of morphing. We'll get more complex in Grasshopper, okay? So I'm gonna go back to my questions, and that will be part 1. We still have 4 more parts to go. Okay, I think we're good with questions. Let me see. Can you guys, okay. So is everyone okay? Can you listen properly? Okay, perfect. Thank you. Okay, cool. So I'm gonna save this one, and I'm gonna give you a little bit of like how to do this in Grasshopper. Okay. For that, I'm gonna open the exercise that I prepared for you guys. like you all have that tutorial. So I'm gonna open the second one here. And I prepared that so that it's easier for you guys to follow, but I will explain every step. So of course, in the master, I mean, we're trying to cover here, like I've done this in the past in 3 days, in all these Maya exercises. So it's very rush. I understand that some people might have questions, and we could try many other things. We could model, quick pavilions, towers, like low rise, high rise, very easily. But for now, I think that covers a bit more of the low poly patterning and blend shaping. So for the second exercise, I prepared here a mesh that I exported. I exported as an OBJ. Now I prepared also like 2 conditions of one pattern. So it's always one. Oh, this is closed. This one is open. In this case, close and open, close and open. And in this case, it's not close and open, but it's kind of pulled up and flat. So we can play with that, okay? So if I go to Grasshopper, what I'm gonna do, I think, is I'm gonna drag this one here, and we can build it from scratch together, the definition. So I think it will be easier for you guys to understand it that way. At least this first one. And then the rest, like depending on how we're doing in time, I can explain it from, so I can explain it from scratch, or I can, or another option is to just cover, like explain the definition, not going through it. Okay, so how many of you, well, that's a difficult question to ask because we can raise hands here. It would be good to have an option to do a little poll. I would like to know more or less how many of you knows Grasshopper, but I guess that's a difficult question to ask online. Yeah, I don't know if you can comment while I prepare a little bit. Okay. Apparently there is some poll tool, but I don't know how to do it. I don't know how to do the poll. Okay. It seems like more or less a lot of people. Okay, Pufferfish is the best. We're gonna be doing a bit of Pufferfish here. I'm sure, like, we can use also Mike if we run into questions. Okay, let me see 1 second. Oh, amazing. So Mike had this poll here. That's amazing. I didn't know we had that option in Zoom. Okay, I don't know if everyone can see it, but I lost the chat here. Sorry. Where is the chat? Chat. Okay, there you go. Chat. At the beginning, familiar. We're more familiar with Grasshopper, fairly beginner. I know basics. Okay, so let's do one thing. So what we are gonna do is to explain, like, just very quickly something about Grasshopper. Yeah, I kind of want to cover the 3 exercises. I want to give it 1 hour to each, but yeah, let me see if I can cover this in like 15-20 minutes, and then we're gonna get back to Grasshopper for 2 exercises. So by the end of it, like, you should be able to understand it. Okay, so Grasshopper, basically we can import any geometry by pressing geometry and right click, set one geometry. I have that selected and it comes here. We have inputs, we have things to output. So you can input or output with the panel actually, but basically once we have some sort of input, a panel will display what we have here. And then something interesting is like you can find everything here on the menus. I'm gonna put this thing that I have called bifocals. So that's how you're gonna know the components that I'm using. If I'm using the shortcut, there are three different ways to display everything. It's with icons, with short names, or with long names, like full names. I like the short names or the icons, but not the full names. It's too messy. So if we have a mesh, like in this case, I can type here, let's say, deconstruct mesh. So I'm not going to go through the menus. I'm just going to be typing, because we're going to do it quickly. So the same way we were doing it in Maya before, I can deconstruct a mesh by plugging my mesh here. And then that's going to give me all the vertices that I have, all the faces that I have, and all the colors and all the normals. So let's say if I connect my panel to the vertices, I will have here like the position of my 287 vertices. Okay, so it's like very quickly I can go to any of them. I can also, let's say, plug this one. Sorry. So actually what we get from the F, this is what I said before in terms of topology. So if I get like, let's say, I'm gonna select item 216. That's going to be my first one. And then I'm going to select 18, component number 18. I'm going to select also component number 217. I'm just going to try to explain you something quickly about topology. And the last one is 251. Okay, and then if I connect them all, in theory, if I'm not mistaken, that should define a face. So, okay, so I'm gonna hide this. So if I set this one to close, okay, most of you knows Grasshopper, from I can see. 88% responded that they know Grasshopper. So maybe I don't need to do too much here. So you see like this F here defines, like actually like many of you might know Grasshopper, but many of you might not know actually mesh modeling in Grasshopper. Like I model NURBS in Grasshopper for, like 8 years. And then I moved to model pretty much everything with meshes when I moved to Saha. So even though I thought I knew Grasshopper pretty well, at Saha we just use it in a completely different way. I'm going to be showing you more like the mesh side of Grasshopper. Anyways, here on the faces, so this is how the topology is defined. So the first phase, so here if I say explode mesh explode, if I were to select my first one, so I'm going to say item 1, that one here, that face, yeah, it's connected, it's connecting 200, the vertex number 216, then the 18 to have 217, 251, which I individually selected here. And I created a polyline to connect them all and define my face, which is the same thing I'm getting here. Okay, so this is a little bit about like how we navigate a mesh here in Grasshopper. And what's important, it's like we don't need too much. Like for now, I think that's more than enough in terms of a mesh. What we want to do is to start mapping components in a mesh. Yeah. So I'm going to select one mesh. Sorry, I'm going to select. There you go. Select one mesh, this one. And then I'm going to be using some of the components to make it quick from Pufferfish. So the first one is called Twisted Box Mesh, I think. Twisted Box Mesh, yeah, that one. Where basically we can create like containers based on each individual phase to host my components that I have here. So I'm going to say 0.2 as the thickness of my boxes. I'm not going to be previewing everything. So it's just only when I click on that, there are two different ways of working here. It's like either you preview everything that you don't unpreview, or this other way of working, which is only like when I click on it. I think that one is a bit faster. So basically, what we need to do is like we need to have a geometry. We need to have containers for my geometry. So for that, I'm gonna also have here, and just gonna say one. This is like how many boxes in thickness. So just one box is enough. And what I want to do is to, oh, I see how I created the pole. Okay, cool. So what I want to do is I want to morph, and I want to say, I want to map a module inside each of these boxes. So I'm going to take, my module. Yeah. So I'm going to select my geometry. I'm going to say, let's say, take this one for now. First, I'm going to do it simple, and then I'm going to do it combined. Okay. So I'm going to take that one, and then I'm going to get a bounding box around it. And then from that, we can use the one default in Grasshopper, or we can use the one that might develop. So I think since we're using already Pufferfish, it's okay to keep using that. So I'm gonna bring my geometry here. My reference box is that one, and then that's the twisted box, like the containers that I was talking about. So basically what happened is like each of these components, each of those components gets mapped to each of the quads. So you see within like 4 components, we can already get like a little pattern that we have absolute control, because I have control over my geometry in Maya, and I have control over my component in Maya. And then here I'm just using it to map it. So what happened here is like each of them, so if I say list item, each of them are separated. Yeah. So if I go here, each of them is like one separated component. So what do we want to do? We want to join them. So I'm going to join each of them into one single mesh. Yeah. But the same thing, joining is the same thing that I explained before as combining in Maya. And basically, after joining, you have to weld it. Yeah. So we can weld using this one because it's something very simple. And this one is the one. So if you don't know where a component is, you can do Control Shift and I think it's Control Shift left or Control Shift right. Let me try it. Yeah, it's Control Alt and left click button, and it tells you what it is. So that's like part of Mesh Plus, I believe. If you don't have that, because all of you will have, I mean, this one, to be honest, like we can just weld it with the basic one. But sometimes the basic one in Grasshopper doesn't weld. That's why I prefer to use this one. Or if not, you know, I think for more complicated things, the rebuild mesh from Pufferfish. I think this is Pufferfish, yeah. That one is very handy. So basically what we do, we connect like the mesh here, and then we just need a toggle. So it says, what does it say? It says like, oh, So it says like rebuild normals. We can say yes. Remove and use vertices, yes. Unify, yes. Flip normals. I don't think you need to flip the normals. Merge duplicate mesh vertices, yes. And then here I just take the distance, which I think by default, I just say that's 2.2, let's say. So when everything is welded, we can apply Catmull algorithm, which is Weaverbird. Yeah, so it's Weaverbird. You should have it download as well, which is the same thing that Maya is doing. And here, basically, I'm just going to say 3 levels of subdivision, and that will give everything smooth. So the same way we were doing in Maya, if we wanted to keep the edge sharp, we'll have to detach the meshes in there, which is the creasing that we did in Maya. But here we need to kind of navigate with the data, the mesh, whereas in Maya we can just select it manually. Slightly different process. But you get the idea. This is kind of where I wanted to get it from now. So this is like a, I can say scribble here, and I can say here simple mapping. And then this can be our little mesh intro. And then now we're gonna do a second one, which is kind of the a bit more advanced one, which is morphing. Morphing, I think for the webinar, for the master, we will be using it a lot in a more advanced way, which is basically taking into consideration some external data. So it's kind of data-driven design. But for now, I'm just going to keep it a bit simple. So I'm going to just take a height as the driving data. So basically, what we're going to do, let me think about this one. So I just copied the same, yeah, for now. So that's going to be the part where I'm morphing. And what I want to do here is to explore each of these faces. And I want to get the center, yeah? So I can do naked boundary. And I can do polygonal center, takes less calculation. And then I can say deconstruct vector. So I'm going to take the center. Those are my centers. And I'm going to get the Z value of each of them. And I'm going to use that value. So basically, okay, I'm not sure. Is this, okay, maybe let me ask actually a question. So is this kind of clear in general? Okay, sorry. I see some questions. So fast. Okay, so fast. Okay, apologies. I realize I'm going a bit fast. I thought, you know, like most of people knew Grasshopper, so that's why I jump a little bit fast. But obviously, some people might not be familiar with Grasshopper yet. So what I will do is, like in the design exercise, I will explain everything in detail again. Okay. You're gonna have the videos anyway. Don't we get overlapping vertices? So I don't think we get overlapping vertices because of the merging. What is the difference between a morph component from Pufferfish plugin and native box morph from Grasshopper? Any special thing? I think Mike is the developer of Pufferfish one. I think like he did solve like some issues that was on the default one.
Hey, it's just multi-threaded.
It's
So it's just a lot faster.
Yeah. Okay, so there you go. So multi-threaded meaning like it takes all the parallel computing into consideration, which is great. Like for Pufferfish, geometry gets a bit heavy, and this essentially is just going to make it all faster for you. So there you go. Well, thank you, Mike. It's amazing to have you here. So yeah, okay. So what we're gonna do is like we'll repeat it like a few times, and if I'm not gonna repeat the exercise, but you have the definition, so you can go through that, and then because I'm going to repeat it later for the design exercise, you should be fine. So let's see. So once we have the data here, so that's the set value of each of them. What we need to do, we need to remap the values. Yeah. So remapping, essentially what it means is like we're going to get the values, all the values. We're going to understand what are the limits, so the bounds. So the limits being like the minimum and maximum value. That's going to be my source domain. And my target domain is going to be by default 0 to 1. So I'm going to get all the values. We put it there. And yeah, so basically those values, I'm going to visualize it. Okay. So what we can do for that is, let's say we can do color gradient, for instance. I just want to, like, for you guys to see it. So I can get my faces. I can do a little custom preview. Preview, and then I can get my values remap in here and then map in there. So for that one, okay, let me see. 256, 256. So I need to hide everything. So basically, like the higher the center of the mesh is, the closer it is to red, and the lower, the closer it is to green. Okay, very easy. No, this is so annoying. I like it so much better with Pufferfish one. Okay, so yeah, that's just to visualize it. And basically what we're gonna do with that, we're gonna feed those values into my twin two meshes. So we're gonna get like one component. So we're gonna get where are they? Here. We're gonna get component 1 to be this one. And we're gonna get component 2 to be this one.
Hey Alejandro, sorry to interrupt. They're just
Yeah.
asking if you can make the Grasshopper window bigger.
Ah, yeah, sure. Makes sense. Okay. Okay, hopefully that's fine. It's a bit annoying for a webinar. Usually I work with 2 screens, but for a webinar it's a bit tricky. Okay, yeah. Okay, so we have 2 components, yeah. So the flat one and the kind of stretch one. And there is another component in Pufferfish that's called twin meshes. So we can get 1 and 2. And basically what we need here, it's a slider. So this is exactly the same thing I was doing in Maya. It was called blend shape. Here is like twinning. So if you see my component, you remember that geometry I did that it was morphing between 2 conditions. So the concept is the same. You have like values between 0 and 1, and then you can navigate in between both of them. So once you understand the concept, like you can apply that to any software. I think that's the important take as well here. So if we have that, what we can do, we can take my values from, where is my mouse here? Take the values from here. And basically what's going to happen is like I'm going to have a bunch of components. So in total, I'm going to have as much components as values. I'm bringing here 256, and then all of them are located there. Okay. So now if I get a bounding box for each of them, so the bounding box being, we can do, yeah, I think like we can do like a union one here. So you just get one of them. And then I'm going to deconstruct, let's call this deconstruct box. Yeah, and then I'm going to do construct box or domain box. And then I can take the domain from here to here. And then this one, I want to just say 1. So I want to keep the box always height, so I can map the height difference between each of them. And then those ones here are going to be it's going to be the same box for all of them, because this is going between 0, 0, 1, 0, 1, 0, 1. I can use the same box in this case. So basically, my reference box is not going to be that bounding box. This is the bounding box in this case. So I can bring that one there. And then that's going to be my geometries. So my geometries can be those ones. Am I doing everything right? Let me see. Okay, so yeah, so you see what's happening. What's happening is like at the bottom they are flat, at the top they are like 3-dimensional, and then here is where the welding becomes important. So if I increase this value, the welding value, if I increase it to, I guess, I don't know, I have to try it, but if I increase it to 0.2, like I weld all these conditions in between. Remember 0.2 because I tried before, of course. Otherwise I have to try it. Okay, but let's see it with something a bit more obvious. So let's say like this one. If I get that as panel 1, and that's what I want you guys to see as well. It's like, you know, I use this a lot in the office when I'm in a kind of quick project, because it allows me this workflow. It allows me to quickly model many different options. And this option, like I have the same gradient. So you need to understand that you have 3 parts, yeah? So basically, I'm always gonna have, maybe I can sketch here. I always gonna have, like in this case, you know, my geometry. So there is geometry first. I'm gonna have my module or pattern. So in this case, you know, the pattern is like a strip. And then I'm gonna have data, which is like height in this exercise, and that all together is going to give me the shape with all the patterns and stuff. Yeah. So that's in my presentation. I explained it. I don't know if it was clear. Maybe worth like showing that again. Okay, actually, like there's not much time, so maybe we'll leave it there. Okay, let me get rid of this. Okay, maybe actually we'll leave it there. And yeah, basically like that's like I could also take this other one, and we could get, you know, more interesting data. Like this is how we get to this other one in here. So once I have it all together, I can make it. Yeah. So the bottom is all solid, the top is open. We could get more interesting data like environment data. So we could plug it to Ladyback, or we could get like structural data, and each of that like could bring information about like how we want to open these patterns. Okay. Okay, so I think that's good. So this is exercise 2, the morphing. So maybe I'll just leave it here like that. So we don't need this bit. You have the exercise anyway, so I don't think I need to save it, but I'll save it just in case. Okay, cool. So that's exercise number 2. And now basically what we want to do, if I go quickly back to presentation, well, what you guys want to do now is to ask me questions. And what I want to do is to open the presentation quickly. I'm going to open the chat. You can drag the camera to side, select the space between camera and Rhino, and drag to right. Now I think because the camera is splitting and get smaller. Okay, Ryan is full screen. You want to make the Grasshopper window bigger. Okay, yeah, I hope like sorry about the Grasshopper screen. Didn't realize. In case anyone missed the email, you can get exercise files here. Okay. Some details missed, but I will see on recording. Okay, that's good, Radu. I'm gonna explain how to do patterns, and I'm gonna explain how to map the modules as well as part of my exercise. So you should be fine by the end of this. Presentation. So I just want to explain. Okay, I'm doing a bit like I'm running a bit behind, but that's okay. So so that's part of what I wanted to explain in my presentation. I had like this little diagram. So this is basically what we did, right? So we have like a geometry already panelized in this case, and then I have a set value, and then I did a pattern based on that. Okay, so I just need like 2 minutes or 1 minute, use the bathroom, and I'll be right back to start our presentation with this one, that one, and this one. Those are the 3 exercises coming in the next couple of hours. Okay, I'll be right back, guys, in 1 minute. Okay, guys, welcome. Welcome back. Let's get started with our exercise. I think this one I really like it, and what I like as well is your screen sharing. Okay, okay. I think you see the exercise. So what I really like about this exercise is that it's very dynamic. It's very easy to play with, and it's definitely like going to be one big part of the explorations we'll do in our masters. Okay, let's see. Is this opening? Okay, so I'm going to close this one. And I think the best thing is to have this one here so I can explain it step by step. Okay. Okay, so I'm gonna switch off camera now. Okay, maybe I can leave it on and then see if there is any problem. Okay. Oh, that's pretty cool. Okay, let me I think I'm gonna switch it off because I remember like this last bit was a bit heavy. I don't want to have like problems with the connection. We'll have a chat after the exercise. Okay, so this is it's kind of like 1 hour late where I am now, but I think I'll try to catch up with this exercise. It should be fine by the end. So let's get started from the beginning. So basically, we're going to be working with 3 planes. We're going to do a bit of topology transformation, and then we're going to start adding detail, more detail. And then at the end, we're going to create pattern. I'm going to show you how to do it quickly here in Maya and how to do it in Grasshopper. Okay. So this is the first exercise, which was supposed to take like, a bit more than an hour. But I think what we will do is to try to shorten it. So, I mean, I'll try to make it a bit faster so that we have time to cover the other 2. So first of all, we're going to start with a plane. Okay. So same old. So in this case, you can see here, I deleted the data. Okay, you know what? Like, I think maybe it can be a bit less distracting if I open a new Maya file. Okay, I don't think it's going to be that heavy. If it gets heavy, what we will do is to open another Maya file for the new exercise. Okay, so you have the steps there. We have our Maya. We're going to open, create, polygon, and a plane. We're going to do, I don't know, roughly the same. This is very difficult to get exactly the same always. But I'm going to say, so 4 squares, I'm going to think that each square is 5 units. So I'm going to say 20 by 15. And basically, once I'm here, okay, I'm going to create the subdivisions of this. I'm going to say 4 by 3. Yeah, so we have the same. And basically what I want is to just to double check. Can you see the screen, all of you? Okay, cool. So let's just move on. So now I want to be a little bit more precise. I'm not going to be super precise, but I'm going to be a little bit more precise. So I want to keep everything 5 units. So I'm going to do a copy, Control D, and I'm going to move it 5 units up. So another way of being precise is with this tab here. So I can just say 5 units relative up. And then I'm going to make another one 5 units relative up. And then what I need to do is to select all these faces and shift right click, face normal, reverse normal. So I need to flip this one so I can bridge in between these 2. Okay. So this is super fun exercise. I mean, I will probably in the next webinar, I'll do like around February, I guess. We'll cover another one of them, and we'll cover like like other ways of creating detail. But this is definitely like one direction. Like if you remember from my presentation, one of the concepts that I wanted to explore is this architectural geometry. So I think like this low poly modeling with these techniques is very fun to use. And then this is the other direction. So these 2 directions will be in my next webinars. Different ones always and different workflows. For those of you who wants to keep doing webinars with me, but always, that's exploring these topics. I think they're very cool topics. So basically here, what we need to do, it's as easy as start playing with them. So I'm gonna take, let's say these 2 in this case, these 2 faces, and then shift right click, bridge face. Take this one, take that one, bridge face, and we get that gesture that I did before. As easy as that. This one and that one, bridge, and we have already our, very smooth geometry, very low poly, and very easy to control. This one, if you think already in Rhino, like I'll already be like, you know, struggling a bit to think how to model it in a way that I can quickly update it if I needed to. Okay, so that's the first step. Next step, of course, with this, I will encourage everyone to try a different one. Try it, you know, I'm gonna show you like, I don't know, maybe, you know, you want to play a little bit with this. So you got another very cool geometry out of that. You wanna get some connections here. So I think with that, like you can get very playful to get like base topologies. And then from there is like how you detail it. Like I think it's important for you also to understand what's the thinking process behind the logics I apply, some of the detailing techniques and some of the patterning techniques. But you know, that could be another potential one. And so on and so forth, like many different ways. Like the important thing is to have a strong first topology that it's quite three-dimensional to then start navigating from that. Okay, so I'm gonna show you how to get there. You know already, I think what I really like about this topology when I was modeling is the continuation of the loop. So you have this loop, is one single edge that goes all the way around your geometry. And I think that's the strength of that topology in this case, because then, you know, I can play a lot with the loop by changing the thickness and the width of the loop and then adding details on it. So you see like here, I added these details here, but like you have this feeling of fluidity and continuity, which I think is what makes the design strong in this case. Every case is different, obviously. So if I go here, I'm going to extrude this one. Oh, camera was off. Okay. I'm going to, I don't know, let's say like 0.4 maybe. Yeah, something like 0.4. And I'm going to select the loop and I'm going to do exactly the same we did before. So I'm going to go to my, I disappear. So I'm going to bring it back here, crease here, and then right click. And then same thing than before, page up, page up, page up. Okay. And then now what we need is to start shaping this a little bit. Yeah? So what I'm going to do is to be a little precise, not too precise, but a little precise. I'm going to move by 2 units. So this one maybe a bit more. This one like that. And then here, I would like to try to keep it symmetric. Maybe one more. And I think, yeah, I think that the flat face doesn't help there. So that's why I'm going to move like that. And then I think another thing that we could use here, it's so this is like this is quite precise way of modeling here. Then something I use a lot also is to come here in plan and start, you know, scaling. The only important thing I would say is to be symmetrical in this case. Otherwise, it's just like you destroy a little bit your concept. I think that for me can make it. And then next step, I don't know what I did here. It's fine. We're gonna do a little bit of detailing of this edge, yeah. And then we're gonna do like a little thickness, making a little handrail. That should be quite straightforward. Okay, so there's some questions. Sorry, I missed out, but why did you flip the normals of the middle plane? Okay, so if I don't flip the normals, Let's check. If I can flip the normals, this will be flipped, it will be inverted. So basically, to bridge, you need like that face and this face to be facing positive and negative, so that, you know, the lofting in between them, it's straight. Otherwise, it will be flipped, because this is side A and side A, so it's trying to rotate it to meet the same topology. So you need to flip it. Okay. Can't bridge two different objects. So you need to combine. Okay. So before you bridge, so if I have separated, I will then be able to bridge. If I select all of them, I can combine it and then I can bridge. Okay. Hope that answers. Okay, we're good with questions. So I'll continue here. So now we're going to start detailing a little bit this. So I want to be using some colors. So I'm just going to keep it, I'm just going to keep it gray, like everything, and black and white. But basically my edge, I want to be able to differentiate the edge, because then later on I might use that as a selection. Okay, I think it's time to switch off camera for the lagging issues. One more question. Could you explain how it will work with a vertical surface? How could you, with a vertical surface? I'm not sure how. So vertical surface, I mean, maybe I'll just show you something here quickly. So you could have one here and one there, yeah? And we could say, I'm gonna combine both of them, and I'm gonna get here, I'm gonna insert like 5 loops and 5 loops. And then what we could do, because this is combined, we could start bridging the surfaces. I'm gonna say one subdivision and smooth in this case. So I can start bridging. Hope that responds the question. I don't know how to respond it otherwise. So we could start bridging things like that. Okay. I don't know if that's what you meant, but yeah. So by the way, like any tool in Maya, you can go to, where are my bridge faces? Because I changed the settings now. If I want to reset it, you just reset it here. Very straightforward. Okay, cool. So yeah. So yeah, I was changing colors here. So I'm gonna get my loop here, and I'm gonna say I'm gonna create a new material. I'm gonna be white, and then basically all I'm doing here is to start playing with the edge. Yeah. So you know, like here I'm gonna start saying, okay, go back here. Yeah. So I'm gonna add this detail here and make it look like more dynamic. And I've been actually very precise because it's all moving by units. Yeah. Yeah. So we can add that detail. Then I think I added like one more step here. So what we can do is add another edge. I'm gonna crease this one, and then we can Yeah, I think I need to move it back. And then, you know, here on the side, we can use that edge to, let's say, I'm gonna move that one a bit here inside to make it straight. And yeah, maybe this one as well. So we'll get that little, I think I have like this side wider to get like a pattern in there. This is all up to you. I'm just explaining you a bit the technique, and then it's a bit like up to you how you model it in your design. I would encourage each of you to try different ones, and then I'll be very happy to see how this becomes like amazing designs in Instagram. You can tag me, as I say before, Gadea, and yeah, like also Design Morphine will be sharing your post. So yeah, we can, you know, play a little bit with this. Maybe that's a bit wider. And here I think I have it a bit more like that and a bit more like this. You don't need to move it by units. Like I usually just work a bit more freely, and then once I have it, I work a bit more with the units. I think for me it was a bit tough at the beginning to understand why I didn't have control in Maya. So for those of you that are a bit more obsessed about control, there's always like I was a bit obsessed at the beginning because I was very much familiar with Grasshopper. I think for those of you that struggle to see that, I'm trying to be a bit more organized here. Okay, so you see here, for instance, I don't want to be using the stepping. I just want to approximate that more or less. Yeah, to get a nice edge. And then basically this is what we do a lot also in the office, is like to start thinking from every single angle and start shaping your building from every angle. So, you know, like I might be doing this a little bit there. I'm gonna move this one a little bit forward here. I'm gonna make it flat by snapping there. And I think, yeah, that one, it's a bit off. Then we can also bring it in from this side. For that, I'm gonna use the stepping again. Okay. And a little bit of detail here and there. So if we messed up, I can always do D and V and scale it down to flatten everything. I'm gonna move it there. Yeah, I don't know. It could be that here to do the opposite, we move it in. I think that's not very nice because then we destroy a little bit the edge. So I don't want to move this one in. Yeah, you can only move it from one side. Okay, I think that's maybe fine as it is. Okay. Okay, fine. Let's say like this is fine. Let me see how we're doing with questions or chat. This one chat here. Perfect, perfect. Yes, 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 yes. What is all this? Yes? Okay, maybe after this we do the little break. I think some people are asking for a break. Let me finish this one and then we do a little break. It's just like running a bit late. I wanted to do a break as well. I'm running a bit late. I want to cover everything. Anyway, like you'll have the chance to watch it back and forth. So if you see here, what I did was to do the opposite sides. I don't know, maybe better to do opposite sides. So it doesn't look like symmetrical. Okay, let's do that. So I'm gonna bring this one back here. I'm gonna bring this one in. And then here I have those ones. And then here we're gonna do opposite sides. So this one goes there. This one goes here. Okay, so we might get an option to do a little break. Just trying to stay on time so you guys don't die here. It's quite tricky to do this long webinars, especially like considering that we start from zero and we need to explain all the basics as well. Okay, so here I can't spend too much time detailing everything, but you have to understand that this will take a bit of time to get it exactly how I would like to have it. Like you see this little kink here, I don't like that. So, you know, that's a better curve, but I need to kind of look at it from every angle. You see that it's flowing nicely, but you know, the more time I spend, the better it will look. But I'm gonna say that this is beautiful and I'm gonna move on to the next. I think the next thing that we did here was to, I want to start separating geometries into different bits. And then I'm gonna add the handrail afterwards. Okay, so what we can do here is to say, I'm gonna take this loop and that loop. Okay, so those are my loops. And I'm going to, I can say shift and detach. So detach component. So basically here, what's gonna happen is like I'm gonna have two separated objects, 1 and 2. So this object, I'm gonna put it as white and then the other one as gray. What's happening here? Okay, nothing so good. Yeah, so you have different levels of subdivision. So I'm just gonna make it max for both of them. And then here, this one, basically what we can do, we can either solve the topology, or what we can do as well is to go here to attribute editor. Attribute editor, I think it's attribute editor. And then here in, I think it's mesh control, no, smooth mesh. We can also do this, which is I say, don't use smooth global. And then I have to go to Maya options and then go to legacy. And then say, let's see, I don't remember this one. So it's not use the open. Wait a second. Let's see. So there's one option here. What we do here is to allow to keep the corners smooth as well. So let me try again. So first of all, I'm gonna uncrease everything. We don't need that crease. And basically what we are trying to do is to get rid of that kink here, which it can be done very easily by like resolving this topology. I can also be a bit naughty and connect these two, create a triangle here, and that will solve it. Yeah. Okay, so, but there is also an option, because this is just a display. You need to understand that this is just a display. So we can do like this one. Forgot how this one. Do not smooth, smooth internal, smooth all. I think it's a smooth all. So I need to put Maya Cadmol Clark, and then here I need to keep it in legacy. So that way the display will smooth out also the naked vertices on the boundaries. Like this is, I mean, it's just like a visualization thing, but I think it's a bit bothering otherwise. Okay, so fine. So same with this guy. Let's do it with this guy. I'm gonna say do the same. I'm gonna unselect this because we don't need to crease it anymore. And then I'm gonna go to modeling, so attribute editor, and then on here, I'm going to say Maya Catmull and then legacy to keep it all clean, at least to visualize it all clean. Okay, so cool. So now we have it splitted into different elements. We can now, so once I have it all subdivided, I can start detailing. Yeah? So one thing we can do is to, let's say, I can add here, I'm gonna add like 10 of them. Bring my tool settings here. I'm gonna add 10 loops. Okay, so yeah. I'm gonna add 10 loops. And we are going to bevel them. Okay, and then basically, I don't know if we want to actually subdivide it just yet. Maybe it's not worth it subdividing that. Let's keep it like that. Otherwise, it's a bit annoying. So I'm going to take here, I'm going to get 10 loops. I'll subdivide it later, but for now, I'm just going to keep it like that. I'm going to reset the beveling one. And I'm going to say 0.5. Okay, wait. What's going on? So let's say 0.1. I think it should be enough. So annoying. Okay, wait a second. Let me bevel this again. So 10 of them. And then we're going to bevel. I don't know why it's shifting the color. It shouldn't do it, but I think it's probably because of the settings of the bevel. So if I go back here, I'm going to change the width to 0.02. Maybe that's it. I don't know if I can remember what's the settings I use here for this one. But a bit annoying. The beveling is a bit crashy, the command bevel. Let's do one thing. We're going to go here to bevel, and I'm going to try to change it. Okay, it's this one. So it's the offset, not the fraction, I think. Okay, let's try to resolve this. It's getting a little bit crashy. Just do it here in a small piece. So I'm going to smooth this and see what's happening with my bevel. So 0.02, so it should be this parameter here. So it's the fraction parameter. Okay, so let's go back. I'm gonna push this one here, and let's try again. I think it's, it's a bit overlapping the geometry, so maybe it's worth cleaning this up a little bit. Maya doesn't like it when it's overlapping too much. So I'm just pushing some of the vertices. So now if I get this one, I'm gonna say, let's say 5, like, I don't know, I don't need to create too many of them, to be honest. What I want to be able is to bevel them. Segment. Don't understand. Okay, maybe let's try it in this one. Maybe because it's all connected. Opa. Because here I didn't have any problems. This once it's all connected, it's a bit annoying for it. So I'm just gonna select all of them, all the loops. I have 10 of them. Just 10 of them, I think it's a bit too much, to be honest. So you just need to click once, and then double click. And once you have them all selected, you can crease. Okay, hopefully it doesn't get too heavy. And then basically, all I'm gonna do, I'm gonna take one of them at a time. So with the left one, I'm gonna remove the stepping, and I'm gonna push it out. We can push it out, or I don't know, maybe push it to the side. Actually, let's do one thing. Let's try to be precise with that one. So we use the same for both of them. So I'm going to take these ones. I'm going to be going to my tool settings. And I'm going to say 0.1. So we'll move 0.1 in this direction and 0.1 in this direction. So that's how I'm getting this little detail in there. Okay. And then here, maybe what we can do is to take, I'm going to isolate this one for now. I think for the next exercise, I'm going to start from a new exercise. I don't know if it's having problems with like too much geometry in my file. Like when you're doing the recording, it's a bit heavier when you are live. Okay, I'm going to press 3 to be able to select them. Basically, I need to select the second one always. So not that one, but second one, second one, second one, second one, second one, and second one, and then gonna lift it up. There's a bit of labor working here, but you get the idea. Okay. So unfortunately, you need to kind of. I listen to a lot of music when I'm doing Maya, so you need to be a little bit patient here to get your patterns. I think any pattern that works in kind of along with your loops, it will always look great. So what I'm gonna do is like I'm gonna model one side and then we'll focus on that side, and you get like you have anyways the geometry for the other side. Here we're gonna do 5, and then I'm gonna bevel them. I seriously don't know why it didn't like it on the other side. Maybe it was too small. Maybe it was too small. Maybe that's why. 0.2 is fine. Okay, and then we can do the same. We get the idea here. I'm going to select this one. I'm going to move it to the side. I'm going to move this one a bit forward. And then that creates that nice effect here. Okay, it's the same idea. And then if you get here, I'm going to take those ones in the front. And I'm going to play a little bit more with that. You know, here maybe I'm going to put it off, and I guess play a little bit like that. Okay, so you get the idea of those edges, and then the other part is how to get the handrail. So for the handrail, what we're going to need, it's need to remember. Thank you. So what I'm going to do is I'm going to extrude that one. Okay. And I'm going to leave it without extruding. And then when I press 1, basically I can take these ones and lift it up. And I'm going to lift it up by 1 meter, just to be precise. I don't know how much in scale is this, but let's say by 1 meter. Yeah, I think that's fine. And basically now I'm going to take the entire loop and I'm going to put in a new material. That new material being glass. I'm going to put it somewhere like blue and then something like that. Okay. And then you can imagine, like, you know, if we had more time, basically I will be modeling the handrail and I will be modeling a lot of details. So just to tidy up this a little bit, I'm going to move this one point up, 1 point up. Okay, so here I can select the other one by shift and drag. So I think it's something like this, what we want. And then in here, I will need to do the same. So I select my edge. So my edge loop goes from here, let's say like it follows there. So I need another one here. So I'm gonna extrude this one. For that, I'm gonna shift, right click, extrude, and I don't do anything. And then I press 3 and I lift this one up. Okay, actually the other one. Okay. I need to go back and I do shift and so I select the one and I shift and drag. So I get the edge of my glazing. Okay, I can also get this one and convert to the vertices. So I'm gonna lift them up. Same here, I'm gonna lift this one up. Same here, I'm gonna lift that one up. So you see like how you get the continuous handrail. And then I think a nice detail to do always is to get that handrail to be pushed back. Make it a bit more dynamic. Okay, so you see like how I start composing each of these bits. So we have like that detail, we have the handrail, which now I'm going to, that should be all glass, and I can detach as well because it became a different component. I'm going to separate the surfaces. And then I have one geometry here, and I will have the other geometry. So it's two sides of this pattern. So if I select all of them, I press 3. Now this one, we can also make it smooth. Yeah, so it's all coming together, yeah? Okay, so now in terms of, okay, I hope this is clear. So that's kind of the second step or the third step that I explained here. So we kind of got to the model, the point where we added the detail. And all is left for us is to create the patterns, which I think is the most interesting one. So I'm gonna make this dark. Maybe in the dark, I'm going to come to attribute editor. On the dark, I want to make it almost black. Okay, and once I'm at this point, what I will typically do is like everything is part of this, yeah? Okay, so it's two geometries. So I'm going to take all these geometries and I'm going to separate it, create a new group, okay? And then this is like my geometry. And then from this geometry, I would like always to keep low poly. A. Okay, and then this is low poly B. And then this is like the edge. And then this is the handrail or the balustrade. Okay, so balustrade and the edge, they're going to stay in this level of subdivisions, okay, which is the same. So both of them has the same. But then for this one and that one, in order to make the pattern, we need to jump into level of subdivisions. Okay, maybe I'll save this one as it is now. And I'm gonna check because I think there are a few questions. We can catch up with questions. Okay, so questions, let me check. What does changing to Maya Catmull Clark legacy exactly do? So that is just a visual thing, but basically, if I isolate this one, that one, in theory, it will give you a kink here if you don't do the Catmull legacy, because basically, like what it's doing is considering that naked vertex here. So it's a vertex that is only connected to two of them, to two edges. That one, it should be sharp, but I wanted to visualize it as a smooth one. So in order to make that smooth, all I did was to come here, yeah, attribute editor. I had to remember it actually because I forgot, but that's how you will see it. I think most of you will see it like that. If you remove that one, leave it as Maya Catmull Clark, and then in the smooth one, here in the Catmull Clark controls, you change it from all edges, I think it's by default, to legacy. Okay, but this is just to visualize it. Like actually, this is not true. Like I'll show you. So right now I have the pivot there, so I'm gonna modify and center my pivot. I'm gonna show you here. If I actually were to convert, sorry. If I were to convert this to sub-D, oh, actually it does take that into consideration. Sub-D to NURBS. Okay, so it actually does work. Okay, so it's a way to take the naked vertices. You can decide if you want to make them sharp or not. It is the same that I'll show you in Grasshopper. So when I'm in Grasshopper, if I go to Catmull, well, in this case, it doesn't apply. Yeah, but let's say like if I show you in Catmull, yeah, I'm gonna say 2. And then right now, everything is smooth, yeah, by default in Grasshopper. But then I can say here that the naked edges, the border condition, I can say to make them fixed. So basically, let's see how it looks. So that's the condition I have now, but I can also have it so that the entire edge condition is fixed, or that the corners are fixed. That's the one I want to show. So I don't know which one is considered as corners. I don't know why it's not considering that one as a corner. But you see like those ones here are sharp. When you make them all smooth, it looks like that. Basically what's happening here, like what to do with the naked edges, in Maya, you can control it by saying like legacy, it will have everything smooth. And then the other one will have those vertices as sharp. Okay, so that answers that question. Okay. What type of music do you listen while you're doing Maya? I listen to minimal or electro music. I think I need to get into the mood with that. How can you make a face planner along an axis? How can you make a face planner along an axis? A planar, okay. So that's an easy one. So I think I'm gonna make it here. So that's by scaling. So let's say like I want to get these 3 ones to be planar. So I just scale it in one direction. So if I want to get, let's say like I mess around and then some of these elements are like that, and I want to make it all planar. If I scale it like this, that's all gonna be planar. If I want to say that everything is planar at that height, I just scale it down. And they're all gonna be planar, okay? Cool. Okay, so that's answer. Bridge doesn't seem to be working for me, even though I combine the planes and flip the middle normal. Okay, that's strange. We'll bridge for some other exercise. Maybe the other one will work. But you know, bridge should be working always. Like if I take this one and that one, I can bridge. That's another thing that you can. Another way of bridging is a bit tricky sometimes. Another way of bridging is you take one, yeah, and I'm going to smooth it. I'm going to make another one. And what you can do also, you can delete, and then you can delete. In my case, I need to flip it. So reverse normals. And then instead of bridging faces, what you can do is to take the edges and the edges in the same order and then say bridge. And I think bridging edges should work. That always works. Bridging faces, sometimes it doesn't work. It's true. Okay, so that answers that question as well. How much do you usually create in Maya? Only base geometry or also handrails and stuff like that in this example? I do create all the details in Maya usually. I think it's important for the geometry to flow. Later on, I rationalize it to curves and then curves to patterns, but yeah, that's later on in the game. Okay, so we have that. So once I have the low poly, okay, I'm gonna have a high poly now. So for the high poly, I'm gonna smooth it as many subdivisions as I want. So 1, 2, and 3. Yeah. And then basically what we're gonna do here. Okay, so let's get back to my, actually, that's not nice. So I think I removed that one. So you see here. Huh. Okay, that's what I thought. It's just a visual thing, yeah. So like actually when I smooth it, unless I convert it here, I guess that will work. Okay, so let's just convert it rather than smooth it. Otherwise, if you smooth it here, like it's not gonna keep the same curvature, which is very important for us. We wanna keep the same edge, exactly the same. Yeah? So I'm gonna type one more subdivision and then I'm gonna convert smooth like that. Okay, so once you have that, so that's gonna be, let's call it A high poly. This is A low poly. B low poly. Wow, I'm doing so bad with time. So I'm just gonna do like a quick one, yeah? So we're going to take all of them. I'm going to say create selection. I'm going to smooth everything. And then I'm going to select, sorry, I don't want to smooth it. So what I want to do is after the selection, I want to triangulate this. And I want to select these ones and I want to delete them. Opa, no, that's not what I want to do. Okay, that's for hexagons, but I don't want to do hexagons. I think, okay, actually, let's do one thing. I'm going to just do a basic one. I'm going to do a die grid. So modify, conform, smooth. Okay, so we need to be level 4. Oh, this is getting a bit heavy. So I'm going to make sure I'm in level 4. So 1, 2, 3, 4. And then I'm going to say convert to smooth. Okay, that's, I think it's even too much, to be honest. Okay, let's go to level 3. 1, 2, 3. I think that's enough because we see continuous edge. So that's what I care about at the moment. Oh no, we can do one more level. Okay, modify, convert, smooth. Okay, fine. So that's the problem for me, like to do it in Maya. Like you don't have that much control over the size, whereas when I do it in Grasshopper, I will have more control. Yeah, but then that requires another level of understanding, which we're gonna get into. Maybe I would like something in between. So maybe one more. I think we need to go with this one. Okay, I think that one is fine. So it's 3 levels. Okay, so once we have 3 levels, so let's say this one is a high poly. And then what we can do is to have the same thing than before. I'm gonna make a copy. And then I'm going to just chamfer all of them by 0.5. Hopefully we're not crashing here. Yeah, and so good. I'm gonna merge. Okay, and after that, that's our new high poly, which is a die grid. And I'm gonna make another copy. I will often keep all these copies. And then I'm gonna do extrude face off. And then here I'm gonna say 0.02, just to keep a little edge. Okay, once I have this one, I need to create another copy, keeping the input graph. So then the second copy, I'm gonna go to here, to my extrude face, and I'm gonna say 0.2, so that one is close. And we can go bigger to make it completely close. And then I'm gonna take both of them, and I'm gonna go deform, blend shape. So same thing we did before. Now in the blend shape, we're gonna go 1 and 1. I'm gonna find which one is the purple one, and I'm gonna hide the other one. Okay, okay, so this one. So this one has the blend shape in, so it's that one. So now what we want to do is the same thing than before. We're gonna start painting. So if I go to my tool settings, that's questions. I'm gonna go here and I'm gonna start painting. So okay, let me see. I think mesh tools, form, lens shape. So I'm gonna start. I mean, this is the manual way, which is basically, you know, I'm going to, maybe what I'm gonna do is to start with everything open and then I will close around the edge. So I will just paint it around the edge. That's one way, yeah. So, and then I will explain it also in Grasshopper for you guys. So you have like, you know, 2 workflows to go about it. So this one, you could get the loop and try to paint from there. Yeah, so here, basically, I will paint the front and I will try to paint a little bit here around the edge. So I think the edge is important to get it painted. I will do the same thing for the other side, but for now, I'm just gonna show it here. So we could paint it here, yeah, like I'm doing. Which is a bit more of a manual way of doing it, but depending on what you're doing, it can be very nicely done. Okay, and then we just float it, and then we get a nice transition between them. So this is one way. So that's how we could get our pattern here. Another way is with Grasshopper. So let's do it in Grasshopper. So I'm going for that. I'm gonna need to keep my die grid here. Okay. Oh, what happened with this one? I think here. Okay, yeah, no, that's the wrong curve that I took there. Okay, and you get the idea anyways. So I think I have my die grid, and then basically I'm going to I took that one, was the inner one. I have to think a little bit about it. Okay, so this one I'm gonna need to subdivide with the same levels, and let me show you in Grasshopper how this gets done. I think in this case, for instance, I would say it's better to do it in Grasshopper. Some other cases, I do it in Maya. So I'm going to do here, so I think we did 3 levels. I'm going to check it here. 1, 2, 3. Important to have these loops continue. Something happened there. We'll have to revise. I think, okay, let's try to solve it so you guys see how to solve it. So sometimes maybe because of the beveling, I lost control over my loops. So I will need to go through all of them again and increase them. So I decrease everything and then I'm going to crease back all of them. And it's important that you drag all the way to the right so you get like full creases. Okay, so what's going on here? you see, like now it's like high poly, so it's a bit difficult. I think it didn't bevel all the way through, but it's a bit late now to change that. So I will need to bevel this again. Okay, we can keep it like that for now. You see some dodgy stuff here. This one, we need to delete it also. Okay, so that's being cleaned up, and I will need to. Okay, something happened there. Okay. I think like what we can do. Let's see if there are some questions. Okay, I think it's fine for now. So something I shouldn't have done is to remove the stepping, because with the stepping I can know exactly, you know, how many units I need to snap. Now here I need to kind of approximate it, but the stepping is very useful. Okay, so because that I screwed, I'm gonna bring this one here. We're gonna export that one. Okay. Basically, all it happened is like here on my edges, I need to be very careful to bevel the entire loop. I didn't double check before beveling. So you need to double check that the entire loop is selected. And then you need to, it's more the beveling more than anything else. I think that's where I had the problem. But I think, you know, like we can keep either the clean edge, or we can keep the clean edge. It's actually like, okay, I did have the stepping in, so that's fine. Okay, so maybe we'll keep that one for now. And then here, all we want, 1, 2, 3, modify, convert, smooth. So I'm gonna bring these guys to a Grasshopper. So exercise 03. Okay, so everything is divided by colors already. Don't mind the handrail for now. I have this one. Handrail, we could redo it again. But what I want to explain is this one, okay? So for that, we could take, let's say, like one of the patterns. Okay, so we have that. I can take one of the patterns I did before. My surface, tutorials. Let me just grab the pattern, and then we will explain the Grasshopper, which basically is the same Grasshopper we did before. So you have the Grasshopper file as well. Let me find it for you. The Grasshopper file I sent. Yeah, it should be this one. So this is the file that you received, yeah. And then I think I'm just gonna grab from here the pattern. So we have our pattern there. I'm gonna bring the geometry close. You don't have to, but I'm just gonna bring it. It's good to keep it in the same place of Maya, so in case you have to update something. But because Maya, I didn't put in the 000 because I was doing examples. I'm just gonna do it like that now. So basically, what we need to do here, okay, Grasshopper again, guys. For those of you that were a bit confused, I'm gonna explain the one that I sent you. So basically, here it's much easier. Okay, there's some questions. Wait. Okay, thank you. I was wondering because we didn't export it to Rhino after. How did you copy exactly in place the other geometry? I copied exactly in place because I always have the stepping. So since I have stepping, I know at some point it's going to come to the same place. I only move it in one axis. It's a little trick I always use. Otherwise, it's just like a bit tricky to to find out where exactly it goes. Okay, so this one, I'm just going to explain it here. So I have the bifocals on. Basically, what we need is you take your geometry, and it's exactly the same thing than before. So that's why I don't think I need to explain much. So I explode. So there's the data sorting is slightly different. So what I need to do is like duplicate the border in this case, and I'm gonna get a curve. Okay, let me zoom in here so I can explain it. So that curve, that's gonna be my attractor. And if you remember before what we were doing, we were checking the set value of each of them. So in this case, I'm exploding the mesh the same way, and then I'm getting all the centers, and then I'm checking the distance from each of the centers of the faces to the curve. So if I make a gradient of this, as I did before, so I can remap that value, and then that value comes here, and I can get like a custom preview of my geometries and bring it here. So if I hide that one, okay, I think it should be super heavy. I know for some of you, the beginners, it might be a bit fast. I try to explain as much as possible, but yeah, like it gets to the point that I need to finish the exercises. So you're gonna have the video so you can go over and over, and then just mind that, you know, like on the master or another webinars, I will be kind of covering these workflows and some other type of exercises, but like in the master, I will explain everything, like, you know, step by step, and then go with you through the problems in the computer. Like it's like usually all these, like we will take a week to explain, and here I'm trying to explain it in 5 hours, just for you guys. So I hope like you understand that it's the same thing than before. I have a curve, and basically the faces that are closer to the curve are green, and the faces that are farther to the curve are red. That can be controlled a bit extra with a graph mapper. I'll show you what this does. So I can do a basic curve, and we can make it a bit more extreme. So if I bring these ones in here, you see, I will have a bit more control over these values. I don't know why. Okay, I don't think it's laggy, but I'm gonna close my Maya for now. I think we'll need to do it as a brand new exercise, the next one, rather than doing it on top. Otherwise, with the live streaming, it gets a bit slow. So how do you make some mass and area calculations of Zaha in projects with this? Okay, so here's a question. How do you make some mass and area calculation of Zaha in projects with this kind of shapes? I mean, in a normal office, numbers plays quite a big role in terms of efficiency and cost control. Okay. Yeah, I mean, I do this every day. I know, like, for many people, this is not the case. I consider myself very lucky to be working on this kind of projects on a daily basis. I don't think, like, this is like a little wish. If anyone wants to build a villa, we could try to build this villa. I don't think this is something I will do at Zaha, but that's why I also can teach it, because it's not a geometry that I'll be doing for Zaha. But if any of you want to build a crazy villa, we can try to build this one. I'll be super keen to do it. But these kind of workflows of patterning and mapping and stuff, I do it every day at Zaha. Okay, sorry. So, okay, so we have these ones. And then basically, so you understand that already, what is happening in terms of data. All I need to do now is to get my pattern. Yeah, so part 1, part 2 of my pattern. I need to twin the same thing I did before. So basically all the components, all the data is coming here. So I'm actually going to bring it from here, from the string one. And I have the bounding box. So the bounding box, I say, I want that bounding box to be up to 1. It doesn't matter because it's a flat component in this case. So it could be less. And then I just map it here. And I map it with this data field that I have there. So basically, if I go back to my field, we have here, let me see if I can visualize it again. So all the green ones will be solid and the center will be open, which, I mean, of course, we could have painted in Maya, but I think it's too time consuming. Yeah, I think, like, for this, Grasshopper is much better. So that's why I'm very much of a big supporter of Maya and Grasshopper workflows. That's what I try to teach, because I do think, like, it's the best way to go around it. So then we combine it, and then it's exactly the same thing we did before. I join it all together or rebuild it. You don't need to do the cut move for this one. Like, that's going to get too heavy because we are subdividing again. This is more than enough. Yeah, like that's okay. Oops. That's a bit heavy. Okay. Yeah, you get the idea. Okay, so this is the second exercise, and then I'm gonna delete these ones and keep that on the background. Okay, so more questions. So how do you make some? Okay, so this is answer. In this type of projects, I have used the principle of machine learning for optimization and preference. So we don't use machine learning for this. We use, like, you need to optimize following physics. So I think, like, for you that are, for those of you who are a bit more beginners, like, let's say, like Kangaroo even, you could planarize some of these phases. Or an optimization process I do quite often, let's say, like in this image, each of these modules is different. I will rationalize it so that I only have like 10 different types or things like that. Why was bounding box turned into a domain box for morphing? So that's it was turned into. So basically, what I did here, I wanted to get. I wanted to keep the X and Y the same, and the set value, I want to always set it to 1, so that I can take the. I'm gonna put the camera a little bit on, so I can get the height of the module into consideration. So I always do that. I don't know. Can you construct a box? I think maybe I could just make a box, center box. I think yeah, that would be the same. So I could just take X and Y size of the box. No, but that's different. So basically, when I deconstruct it, it gives me one domain, and that's what I can fit here. Okay. How do you deal when you have a lot of polygons and heavy geometry? I guess you have huge and super powerful machines. Actually, not. Like I use a very modest machine. I think it's more about like knowing the workflow. Like meshes, just for reference, are 100 times lighter than NURBS. So if I was doing all these geometries with NURBS, like my computer wouldn't take it, even for this webinar. When I work with meshes, it's just much lighter because all it needs to understand is like location in X, Y, and Z of vertices and the interconnection between all of them. Do you optimize with k-means clustering? Yeah, we do k-means clustering. Like it depends on each of the project, but yeah, that's one of the tools for sure. How do you get just 10 different polygons while maintaining shape in the optimization process? I mean, like, yeah, like that's like, let's say like if it's a flat surface, yeah, that flat surface, I can have 10 different sizes and I just divide the range into 10 different variations. And just by saying like, you know, you can be anything, like you need to stay in between 10 elements. I think like even Mike has one component that kind of does it in Pufferfish.
There's a round near it.
Oh yeah, that one.
There's a workflow for that.
Run to nearest, no?
Yeah.
Yeah, so that one is useful, you know, like you just give like how many of them you want to have. So let's say like if this is your color, let's say here.
Well, there's an example file for
It's example file, yeah. So you
yeah,
can just check in
Pufferfish.
Yeah, Pufferfish, you have an example file for that. That's one of the steps on rationalizing. There are many steps. I think depending on the project and the budget, you need to identify where you can spend your money, and then, you know, depending on that, sometimes you want to have them all different. I don't know, but maybe there's a lot of color gradient that you want to keep in your project. Okay. How would you export from Maya to SAP in case you may need to make small changes in your base geometry? I keep always my Maya, like in all the projects. I keep my Maya file and my SAP file or my Rhino file. And if I need to change that, I go back to Maya. Like I keep the automation process from Maya to Revit, all kind of in a pipeline. What is the role of an architect in the structural optimization of this project? Well, I think the role of an architect is to, first of all, keep control of all the coordination between consultants, and then make sure that the feature qualities and values of your project are still alive by the time you finish coordination, which is not easy. Like, you know, if you leave it to an engineer, they will tell you do a square. Like, you know, if you do a cube, it's going to be good. We're all going to be happy. We're going to make money. But then as an architect, you want to have like design features, you know, like qualities, and make sure that your client is going to be as happy as possible. So I think that's our main role. Do you keep concept polygonal modeling in mind while coming up with architectural geometry? Yeah, I think so. I think 100%. I think I do see polygons in every shape. So yeah, definitely. Okay, maybe I'll keep going with the second exercise, guys. Cool. Very happy to see a lot of questions. It's good that you guys having interest. So for this one, I'm going to, maybe like if you want to have like a 2 minutes break, it's a good moment. And then I'm gonna maybe grab some water and join you again. Okay, just like a 1 minute and I'll be right back. Okay, so I see a lot of comments and stuff about optimization and rationalization. I think that will be part of the master. Like I don't mind in the master to spend a bit of time. I think that's, you know, like it's a chapter in itself. Like this is one step on, like, I mean, with the morphing, you're not really getting rationalize models, right? Because each of them is slightly different since you are just mapping. But we can definitely look into like how to further rationalize this. And we can do it like, as I said, as a part of a longer course, like let's say within the master. We did some of completely on machine learning. Okay. I mean, I haven't used myself much of machine learning. I know Saha Code is using it for a number of things, but I haven't used it much myself. Because of you have done the construction process, we need to think practical in coordination with artistic freedom, and that's machine learning and silvery and while I see payrolls for fabrication. Okay, yeah, cool. Yeah. Okay, so let's like the next one. I think like the first one was very freeform based. The first kind of round of things that we did. Now we're gonna do a little bit more of voxelized versions. So for that, I'm very tempted to just kind of explain through a little bit the process because we definitely supposed to be half an hour left. And I think like I just explained a bit too much. We had quite a few questions in this webinar. So this, it's quite straightforward. Like I think the process is not as complicated. I think it's worth explaining a little bit step by step. So I'm gonna show you as I model it, yeah? So basically I'm going to get like 2 voxels. So I'm gonna say 10 by 5 by 5. And then I'm gonna get like 1 loop here in between. And then basically that's my voxelized system. And then we know that taking 2 voxels, then we can arrange it in different ways in 3D, and then we can map within voxels. Yeah, we'll explain that workflow can be done here in Maya, or it can be done also in Grasshopper. So once we have these 2 voxel space, what I did here, basically just adding a little bit of detail. So that detail, we can just do for now the chamfering, the beveling of these edges here. So I'm gonna bevel, and then I'm gonna keep like that, 0.1, 0.1, and then here and here we can extrude the face, and then I can say 0.2, sorry, 0.2, and then let's bring it in. And then the next step in here, as you can see, I added another level there, and then I pull one of the faces out. So I think we have that one. Okay, actually, what we want to do, I mean, step back. We want to extrude it twice. First extrusion is this one. So here in extrude face, I'm going to say 0. And then I'm going to extrude again. Extrude face again. And bring it in. So we want to keep that face there, completely flat. So that then, as you can see, then what I do is like I pull out that edge. Okay, and then the other thing is, okay, so this is the first step, let's say, and then I'm gonna push it back. And here, basically, what I did was to, as you can see, I created a little bit of subdivision to be able to pull from both sides. So one edge here, and then these ones, I pull it up. These ones I pull it back. And then I can crease the whole thing here. And then we want to crease also here. I'm going to pull this one out. And basically, we're going to add 2 more loops here. So that I can add this detail. Okay. And this one, we want to also grease. And that's giving me already a little bit of the base geometry. So this exercise is more about like detailing one unit, and then what can we do with that unit. In this particular one, the first one, it's going to be done all in Maya, and then we'll do it using Maya and Grasshopper. So here basically I added a little bit of detail. So I made that one dark. I make that one. This one's going to be white. White. And maybe this edge can also be white. And then same applies here. And this one and this one. So if you see that I always repeat more or less the same steps. So I start from a very simple geometry. I get to the essence of that geometry. And then what I like to do is to shape it a little bit. So like, let's say like here, if I want to shape it, but don't lose the geometries as I have them, I think like it's still worth to pull vertices. At some point, I will explain also how to deform it manually. So, okay, so I'm gonna delete this one for now. And now I'm gonna create one more. So I'm gonna say one loop here. We'll have a big round of questions at the end. And I'm gonna try to stick with time here for now. Okay, so we have that, and then, well, you guys are all experts now. You know how to get this detail. So that detail, if you see, it's being increased, and then it's a step. So we can do that here. So what I can do also is to add the handrail. So in order to add the handrail, what I'm gonna do is to make a copy here. I'm gonna delete. I'm gonna select this one, Ctrl-Shift-I to keep the loop. And then this one, I'm gonna extrude it, keep it low. And then I'm gonna delete that one. And then I know now that if I push this one the same way we did before, that's gonna give my handrail. Okay, which I can now put it as glass. And then if I bring this back, I have handrail and this one, which I can combine to keep it all organized for now. As glass. Okay, sometimes the materials are a bit funny. We don't want to change. Okay, and now I change it back to glass and it comes. Okay, so that's my little unit. Okay, pretty quick model. Of course, you know, like if we have the time, I will start adding these kind of details here, which I think it adds a lot at the end. Right? You know, the small things. Then we can add some pattern, similar to what we did before. I don't know if I add pattern here. Yeah, I did add some pattern, but maybe I'll do the one on the side, which I think is the key feature in this project. So for that, you know, same than before, I'm gonna add 5 and 5. So I'm gonna add 5. I'm gonna say select, select, select. I'm gonna bevel them. I'm gonna say I want to keep it very, very small. Okay. I need to crease it. And then I think what I did here in this case is to pull just the vertex. But as I say, like, you know, this you can play with. I think it's just too much. So I'm going to pull it 0.2. And then same here. Yeah, pull it out, pull it out. So when I smooth it, I get that effect. Okay. And then I don't know, like, you know, this thing here, it really bothers me now. Yeah, but unfortunately, I don't have much time. But yeah, I think that's more or less resolving it. Okay, and let's say this is what we want to do. Then, so that's fine, that's fine, that's fine. And then here, I'm gonna do the same. I'm gonna do 5. And I'm gonna bevel them. One subdivision, 0.4 in this case. 0.4 is way too much. I think 0.05, and then I select, 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 select. I think in the example I did it with more subdivisions, but of course I have more time. So here we're just reducing the numbers. That is the same technique. And then here you have the files anyway, so you can see exactly the design. So it's something like that. Yeah? Very simple. And then once I have that, the next step, which is a little bit of a tricky one, like, you know, this, I will advise it for a concept, but then it will need to be worked out differently. So it needs to be properly modeled. So here I'm gonna mirror cut. That's what I did. It's a little bit of a cheeky movement, but it's very effective. Okay. Okay, so mirror cut, basically what it does, you can do it also with Pufferfish. Mike also brought it to Grasshopper. Personally, I prefer it here for what I do. I feel like I have more control, but it can equally be done in Grasshopper. It's no problem. And here, when you go back to your attribute editor, channel box, mirror cut, you can still control it. So I could control if the position it needs to be changed. Even if you lose it, you can always press T and then you go back. I see a lot of questions coming for the questions. So the part that I really care about is here. So I need that moment to be looking nice, because basically the next thing I'm gonna do, I'm gonna make a copy of this and I'm gonna do another mirror cut to complete it. Okay, a bit heavy. Maybe I should delete the previous one. Yeah. So this is what I did. You can play with that. The next step. So if it's okay, I'm gonna delete these ones. I don't think we need them. And then even this one. The next step is to shape this. I'm coming for the questions very soon, guys. So, you know, if I still want to shape it a little bit, I'm gonna remove this one. Agree? I can press T. What is T? So T is for transformations. Should be able to press, no. So T, I could only have it copied here because I didn't copy with the input graph. So, okay, so that's why I keep always like a copy of every step I do. So I know always I can step back. Yeah. So basically why I made here another step is because now something we can do, this is a little trick as well, is to use a lattice. So we can say 3 by 3 by 3. Yeah, sounds right. So a lattice, what it does is like it helps me keeping the same topology. It helps me shaping this a little bit. So I don't know, I can, you know, start stretching some of these moments. Maybe I want to okay, that's too much. Maybe this one needs to be maybe like that. So it's a bit, I just don't want to have it completely symmetric. The center needs to be, I think, in the same place. And these ones, we're just gonna move them a little bit around. It doesn't matter this, it doesn't need to be the same. You just can play with it. But I think like, because it's off center, like it doesn't bother me as much. So once you have that, you can make a copy. So you see like only with few polygons, you can deform it. And then I'm wrapping up this exercise, and then I'll answer the questions. So basically here, all I need to do this twisting is a little bit of a trick. So I'm gonna snap it there, and I do Control D. I'm gonna rotate it there. Maybe move it a little bit to the side and a little bit to the side, and press E for rotation. And I'm gonna rotate it by, let's say, 10 degrees. Yeah. And then I'm gonna do Shift D, Shift D, Shift D, Shift D, Shift D, Shift D, Shift D. So it's a very cheeky one. But basically what this does, I mean, I'll have to, okay, this is a little bit off. Talking about optimization, and then I'm doing something off. So what it does is like it keeps the transformations. It's recording your transformations. So I can rotate this a little bit. Or maybe we just do it like that. And I can make copies. Okay. So basically, as you can see, this is the one I had before. which we can quickly show you a little. I'm just gonna put a couple of lights and see how it looks like. Okay, 3 questions. It's not too bad. I mean, you know, we have 2 more exercises. It will be beautiful. Okay, ask a question because you told me construction project. Okay. Okay. I don't know if it's frozen. It's not frozen. And let me take the moment to answer questions. Where do you choose the loop number again? So the loop number, okay, I think this is like, I think it's a little bit frozen. Let me see. Oh, no, we're fine, we're fine. Okay, so the loop number, I'm just gonna do it here on the side, yeah. Okay, sorry. Let me create a little plane here.
Hey, Alejandro, your question box is like blocking the screen with like that grayed out box thing.
So you get it grayed out instead of seeing the.
Yeah, it's like a privacy thing.
Okay, okay. Instead of seeing the comments, I felt like people could see the comments there. Cool, cool. Okay, so here is where you get it in the tool settings. Like I click here, and that's how I get the number of loops. Yeah. So where do you choose the number of loops? Okay, that's answer. What's the process to come up with designs like this? Do you envision a final form first, or you start with a unit and tweak it along the way and see how it turns out? I think it's a bit of back and forth. Like I do some little sketch. I have inspirations. Like I think in a way, like my presentation tries to explain that. I don't know if it came across in my presentation, but you know, like I do have my inspirations. I look at some of these forms, and then I think I have an understanding on, you know, based on projects that I work on. Like I have an understanding on how to get there. Like I have my, you know, I think about what I want to be teaching, because at the end of the day, that's the reason why I'm doing that. So if it was like a art piece or something, I would probably model something different. But I have these kind of workflows that I know is what I want to be teaching. And then I start producing. And then I look at the model from many angles and back and forth, try different things. So probably to get to this one, I did like 5 of them, you know, slightly different things. And then I realized this works, so I go for that. I'm happy to understand this workflow, but can you say that in Zaha you use parametric tools, but not parametrical design in the search of optimization for the building? I think, I mean, what's the difference between parametric tools and parametric design? Like, I mean, we don't like start typing numbers and expect some numbers to produce something that looks nice. I think that's the wrong approach, and that's a little bit of the danger zone for me when it comes to parametric design. I think it's important that you have the freedom of, I think, you know, Zaha Hadid wouldn't open a computer herself, so she will have an intuition, and then she will draw like very powerful strokes that will drive the design. I think being able to draw these strokes is the most important thing, and you know, you add the detail and all that with parametric design. So it's a little bit of a combination. Maya is very good to draw the first strokes, and then Grasshopper to add the detailing. Okay, there's a lot of questions, guys. I'll try to get back. We'll take it in steps. I think this is clear. And then, you know, like if we want to, maybe I want to isolate this one, and I'm gonna create like some lights, so we can just to visualize it a little bit. So I'm just gonna bring it here and here. I'm gonna scale up this light. And then another light here. I think with that, like, we can start seeing the tower a little bit more dramatic. We can hide the lights if we want to. And then, you know, we can take a screenshot from here. So, so I have these two on. So these ones are nice for the screenshots. It's a bit heavier, but yeah, and you get some nice moments, as you can see with your geometry. Of course, so I think right now I don't have this one. That one is important to get the sharp edge continuous. And then this is the ambient occlusion that always adds. So if I get my light and go here and the channel box. I just don't want to get too heavy with the file. But you get the idea. You can add lights on render it in V-Ray or render it in Keyshot, depending on your skills and your interest as well, or what kind of results you want to achieve. I think I do both. This one I think was done in V-Ray, the renders I shared, but can be done also in Keyshot. Yeah, that's a little bit of the workflow for this one. Okay, so this one is good. Maybe I'll answer some questions while I open the next one. You have the files, so I think like you have all the steps there as well. I try to make it very organized, since I knew we will have questions. So let me save this one here. So this is going to be part 4. In part 5, it is similar, but different. You know what I mean? So it's just like a different way of like distributing the components. It's a little bit of an introduction on how to do it in Grasshopper. A little bit more control than this. I think this is good for a concept, but then, you know, if you needed to start doing something else than just this simple operation, then you will have to do it like a bit more manually. Whereas I like to have control and being able to. So everything I've been explaining is like reversible and is undestructive in a way. Or if it's not, you know, if it's destructive, I always have these little steps, so it's easy to get back from it. So can you briefly show us again how the mirror cut tool works? Can you use it on any axis? Yes. So, okay, let me explain that one. Mirror cut, I think that question is important. So mirror cut, I get it there. You have axis X, Y, and Z. So I can do I'm positive and negative. So I can do it in Y. But you know, in Y, in this case, it's not that interesting. So I can go here and say, no, let's do it in X. And then you have basically the mode, which is merging. And then the merge threshold is the distance for merging.
And then there's smoothing angle as well. And then something I like to do when mirror cutting is to add a little bit of rotation. So I think the mirror cutting is one of these tools that actually surprise you sometimes. So just to give you a little bit of a background, this cut mirror cut, this one here. I don't think I put in the presentation that much of mirror cutting, but yeah, I've done quite a few with mirror cut. I think it can be quite strong, and we've done a lot of research on that and Bartlett. And so like, okay, so that's that. Can we create paneling and crease depressions in Maya? Paneling and crease depressions. I don't know what you mean by depressions. I mean, create paneling. I think I explained already how to do paneling. So I think anything related to patterns can be done in Maya, if that responds to your question. Which is the best rendering engine for Maya? V-Ray, Keyshot, Arno. Well, it depends. Like you have Maxwell as well. I think Arno, like I know a few people that use Arno. I like V-Ray, but Maxwell, I think for concept rendering is also quite good. And then you can always export to Keyshot very easily. If you want to be a junior at Saha, do you need to continue learning how to use these softwares? The junior architect, Saha, do you need to continue learning? I mean, the more you learn, the better.
I think you need to know Maya to be anything in Saha.
Yeah, I mean, I don't know. Like, you know, to be honest, like I do like designing a lot, but you know, not everyone likes designing. We have a lot of technical people at Saha, which you know is equally or even more respected, because you need to be able to deliver these projects as well. If you want to be a designer at Saha, you need to know Grasshopper and Maya. It's no brainer.
We had a question before, and it just came out now. They're asking like, is that model parametric? For example, if we wanted to change the width of the module, would change the tower? And I answered someone before with a similar question that would be like more like duplicate special.
Mm-hmm. Yeah, like I think I would like to do like it's just like was too many things to show in this one, but then there are ways to basically map within Maya and using this kind of replace object components. So you can basically like design your arrangement with boxes like that. That I did a lot for some of the images that we prepare for the master. So arrange a lot of these boxes and then just replace them, like more of a kit of components approach. But then I think the next exercise, I'm still gonna explain one more. I'll try to be fast. The next exercise with Grasshopper, it will help understanding this question. Okay, I'm gonna jump to the next exercise and then we get more questions. So the next one, oh, sorry. So the next one had also a Grasshopper part. And then for the module, I'm gonna use the same module, so we don't need to spend time modeling the module. I think this is one of my favorite workflows. So that's why I wanted to bring it here. So, okay, the module, easy peasy. We have our module here. It's the same thing I did before, but without all the creation and stuff, simplified. Now, all I need to do here is to, you know, get some nice looking base geometry. Yeah. And then I'll export that and use that to map my components. I do that a lot at Saha. So let's say like I'm gonna do my little tower I think maybe worth starting a fresh file. The sound was not clear when you said how to repeat the last command to build the tower.
I think they mean the shifty thing. I think they were confused because someone was asking to know that you shouldn't let go of the gumball, like you shouldn't exit the transformation.
Yeah, so I think I forgot that. So let's say here, if I do Control D, and then I press this one, I move it there, and then I rotate it here. I can do Shift D, Shift D, Shift D, Shift D. So basically, you know, like I copy whatever transformation I have here. So rotating 20 degrees and moving that much, it will copy that and add it to the next one. So you see it's like 40, 60, and it's all kind of done in a sequence. So quite easy to control it. Which, I mean, another way of doing that, and I think it's quite great as well, it's is the duplicate special here. But I think I kind of like this way. Then you could replace these components with something else if you wanted to. Okay, so on to the next thing. I think, so let me just have a look at what we have here. So we model something similar. I don't have anything. I don't have something. Yeah, so we're going to start with a cylinder, and I'm going to delete the inner face, and then we're going to create some slabs, and then I'm going to push in and out, deform it a little bit, and then export. Okay. Cool. So we're going to start with a cylinder here. So here, I don't know, I think, I'm going to say 200 meters and like, I don't know, 30 diameter. And then you need to understand that in low poly version, to make a circle, all you need is like 6 points, 6 vertices. So an hexagon is already a circle. I think that's important because you don't want to add extra subdivisions if you don't need them. So I'm going to delete these ones. And then I'm going to fill these faces. So fill hole. And then fill hole again. And then here, so I'm just going to eyeball it. Like, ideally this is kind of connected to your massing. So like usually I will have a Rhino model that is completely parametric and is meeting requirements from the brief, and it gives me all the GFA and all the all the numbers that the client needs connected to this massing here, and then in Maya I start shaping it to get some design elements that I'm interested in. So I keep developing both in parallel, and then once I have these two kind of connected, so let's say like maybe that's my Rhino model, yeah, and then here I will start doing like maybe I'll start thinking about it and say, okay, so there is not that much things that I can change in this model. So here actually I'm gonna add another little extrusion. So in order to be precise, I'm gonna move it up here. So all of them are the same thickness of the slab. Of course, the slabs I use a bevel, but I will be a bit more precise. and just need to do it, This is an exercise I need to do quite often, which is like modeling a tower in 2 hours. And it's just the way it is. Like, we have to submit models every single day. Sometimes you just need to know how to do it fast. And then once the concept is approved, then it's worth spending more time on it. Okay, so let's say like, cool, this is what we want. And then I'm gonna select these faces. Sorry. And I like to keep 2 materials for the selection later on, and also because when I bring it to Rhino, it's split already, which is very useful. Okay, so these ones, I'm gonna create a new material. And then I can do Ctrl-Shift-I and I get the other faces, these ones. And basically what I want to do, like for a quick exercise, is to extrude these faces. I'm gonna extrude them all by 3, and I'm gonna increase these ones as well. And then basically I'm just gonna do like, a little bit of tweaking some of these labs. So again, I think, just to be a little bit consistent with the dimensions, I'm gonna have a little step. So maybe of 2. I think maybe 2 is even too little, 5. So, these cantilevers, you kind of want to have also control over them. It will become a whole discussion with your structural engineer, how much you can cantilever. So typically, this is something I will still do in Maya. And then later on, I will convert it to curves and work it out in Grasshopper. So let's say something like that is fine for us. Maybe we'll add a few more in the other direction. You see like how quickly it is for me to model something here. So if I wanna go in this direction, I'm just gonna snap it there with D. Okay, it's fine. And then, well, you know already the tricks to add a little bit of detail into this. I don't think I have much time here, but I will start adding a little bit of that. Maybe I'll just add a little moment there. We will detail handrails and stuff like that as well. In this one. Okay, so once we save this a little bit, I think the other thing I did is a little bit of a cheeky trick here again. I like my cheeky tricks. Is to use my lattice box and then add like 4 subdivisions. And basically I rotate these. So using my step tool. So using this one, I'm going to say 30 degrees. and I'm gonna rotate everything just with a lattice. Okay, so a little twist box here, and then, you know, like, I think it's still worth to. I think what I did here was to move a little bit like that, a little bit like this. And of course, I'm trying to spend it very fast, but I take a lot of time to you know, think it from every shape until I'm happy with that. But let's select it. This is okay. It's not extremely bad. And then I'll make another copy. I could do it as NURBS, but I'm gonna do it as a mesh export, as an OBJ. I think like even, okay, no, I think this is fine. So convert smooth. Okay, actually, like I need to go up in subdivisions. I'm gonna press 3. And I'm gonna go 1, 2, 3, 4. I'm gonna do modify, convert selection to smooth. We're gonna export it as meshes. Then of course we could do it also as NURBS, which for this exercise, I think I will do it as NURBS. Yeah, no, but like I think I prepared it as OBJ, so it's fine. So exercise 05. I'll get back to all the questions later, guys. Promise. Okay. 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 Well, it doesn't matter. I think it's just that I could just open a new one. Okay, so you receive this file as well. So basically, we export that from Maya, same way. And then we're going to start preparing our geometry here. So I'm going to import my exercise 5. So that's the export from Maya. Okay, it's a bit bigger now. I think I didn't have time to control the scale. Usually I will have always like one person for scale reference. So this is a little bit object driven in this case. I'm designing an object, but obviously I will always have like more control over this. So, okay, so here are actually interesting. So when you export as an OBJ, you have to unselect it and then select it again before you export, or at least that happens in my Maya. Otherwise, it doesn't work well. And it exports one of the geometries as one entire mesh rather than splitting it properly. Sorry, this one. Yeah, so now it's exported properly. And those are the ones I care about. The other one is just Maya. So let's do this one. And I'm going to open my fourth Maya, my other Grasshopper definition for that. Webinar. So I did a little bit of rebuilding the meshes here. So it needs a little bit of a preparation of a low poly, this exercise. So let me explain it, or maybe it's worth actually doing it from scratch together. I'll be fast, but maybe worth doing it. Okay, yeah, I'll explain it, and then if there are questions, I can answer them. So basically, this is the geometry I care about. Yeah. So I'm gonna do explode and split this joint mesh. Yeah. So we have all our meshes are separated. Split this joint mesh. Yeah. So all of them are separated. I'm gonna do here my bifocals. You all have this exercise already. And it's a very straightforward thing. Like it's the same thing we did before. The only difference is like I took each of these high poly meshes and rebuild them to map the modules. So first of all, we get our naked boundaries, so top and bottom. So a little bit, I know this color. Yeah, just gonna leave it like that for now. Let me remove the grid. Yeah. Okay, so I have my bottom and top curves. And then what I needed to do here is to make sure that the seams are starting at the same point. So what that means is like I take the curve at the bottom and I say, okay, evaluate that curve, give me where the starting point is, which is 0 here. And then that point, I check what's the closest point on the top curve. That's my closest one. And I use that to rebuild the seams of my top curve. So I make sure that when I'm lofting, like both of them are aligned. So by doing that, I can join those two curves. You have the whole definition anyways. And then here I have this parameter that I can shatter the curve. So shatter is subdividing the curve. So I divide it into these points, and then I use those points to define the point on the curve where it needs to be divided. And then with that, I'm shattering the curve. I rebuild it as one single degree and 2 control points, so a segment line. So it's a polyline. And once I have that, I will be able to loft in between. So by lofting in between, I will create the faces where I'm going to be mapping my modules. So if there are questions about that, like I can explain it in detail. I just like thought maybe we won't have the question. So here, what I did for the math mapper is basically I need each of these trees to be organized. So what you see there, where it says n equal to, those are how many elements I have inside my inside the branch of my data tree. So basically I need to have groups, so boxes with 2 curves each, so that I can loft in between them. So I'm lofting in between each of these segments. Okay, so here, before I do the path mapper, I have kind of everything defined in trees that are divided into 2 subcategories of branches. And then I use that one to say, Okay, so that's my tree structure. Basically, those components that I have here becomes my third branch, and then B becomes the elements that are contained in there. So by doing that, then I've loft. And once I have the surfaces, this I think is the important step to understand how to build this low poly mesh for mapping. So once I have the loft, I extract my vertices, okay, and then I list item them. So I have 1, 2, 3, 4, and then I construct the mesh with the topology of the mesh being 0, 1, 2, 3, meaning that you are going to connect vertex 0 to 1 to 2 and 3. So all I need to do here is to bring my vertices in list of 4, which I get from here because everything is divided into phases, and then get them in the same order to come here so that I can construct this as a mesh. Once I have that, I can join and weld everything. And I did the same for another curve I did here. So it's essentially the same one that I had there. I offset it out, and then I did the same division, the same process. So it's the same steps, so that I get an outer mesh and an inner mesh. And then within these two, what I can use is the twisted box between two meshes from Pufferfish, that one there. And I can create a box in between these two meshes. Yeah. Once you have that box, then it's the same process that we had before. So I need to connect my component. So it's that component here. In this case, what I do is, because I have like 3 different parts, I have 1 part, 2 parts, and 3 parts. I group them before I create the bounding box. I create my bounding box, and the group, I take it as a geometry. This morph to twisted box, like it takes the groups as one geometry. So I can basically say, okay, so this is my bounding box, and that's my component, and that box is going to be remap to each of these boxes here. Okay, each of these boxes that I have here, my target boxes. So once I have it all remapped here, I can ungroup it. Yeah. So basically, I'm going to have now, I have 100, so I had 127 different groups with 3 geometries inside each of the groups. So basically, each of these cells contains 3 geometries, which are the 3 geometries that we have in our component. Balustrade, cladding, the white cladding, and the black cladding. So if I flip that matrix, what happens is like I have everything organized by geometries. What does it mean? So it means that if I get a branch from here, so if I get that branch, basically now I'm highlighting all the glazing in my geometry. Now I'm highlighting all the cladding, or I'm highlighting all the white cladding. So that's a way to keep your geometry very organized. And then you can join each of them, make sure everything is well, and then you bake it. Okay. I will do more webinars about this, but you get the workflow, you got the script, and you get the idea. And I think like this needs, I thought like it was important for those interested in Grasshopper and those that are a bit more advanced in Grasshopper to have an understanding of this. Of course, I understand it's a bit rushed, but it's good for you to have it there. And that's basically something. So if I go back to my presentation. So that's basically, this was kind of similar workflow, slightly different, but you get the idea. a bit more complex, obviously, and a lot more constrained. This is the idea of some of the stuff here, although that one was done just in Maya. And this is the idea of this, which is the one we cover. And the idea of some of, I mean, it's one of the directions, which is the second direction that I will be kind of researching more in depth as part of my master's. And so, yeah, one option, or one direction that is very fluid and very, you know, artistic based, more like, you know, big stroke, big movement in your architecture, understanding that there is no differentiation between horizontal and vertical planes in architecture, but more of a kind of continuous element. So very much interested in this idea of rheophonic surfaces. I think I explained already in my introduction video with parametric architecture. And another direction that it's a bit more rational. It's more about like living units. And I think it's, you know, both ideas, it's something that I'm definitely going to be exploring. Plus this, you know, we'll get deeper into pattern creation and subdivisions and data fields, and informing these data fields with, you know, with user-driven data and with environmental-driven data. So, you know, in this case, maybe you have like lighting coming through spaces that you want to have light. In this case, maybe, you know, the pattern is connected to structural reasons. In this case, it's more like purely design oriented. So we'll be having a lot of discussion about that. And yeah, I hope I can also prepare another webinar to, you know, like to keep that discussion and keep looking into some of these ideas with you guys. I'm gonna go now through some of the questions. From my side, I think I cover all the exercise I wanted to cover. So in our model, is our model parametrical? For example, if we want to change the width of the module, will it change in the tower? Yeah, I think especially in this last workflow, it is all absolutely parametric. So cool, done. How do you continue to tune your skills as a designer? I think like it's more about collaborations. I think, you know, Design Morphine for me is a great platform to keep discussion with some of my colleagues. And I have discussion also with colleagues at Saha. We all have different interests, different workflows, and, you know, that's the way to keep learning and collaborating with friends. At Saha, peoples which are great in drafting like AutoCAD. Yeah, I mean, we do have great people in AutoCAD, although I think AutoCAD is a little bit outdated and very complex to stay tuned with the pace of some of this modeling. So I think, like, you know, there are designers for details and people that just looking into the detail section. They're very experienced and they have a lot of experience in construction. So more technical people. So all are proficient in computational design. I think that's part of the same question. So yeah, I think everyone has a little bit of an idea of computational design, and then some people are more technical. So I'm very much interested in design, and I focus on kind of what we call the makeup of the building. So a little bit of the exterior, the facade, and the interior, and then whatever happening between that sandwich is more of the technical side. So I give a zone, like literally I give a geometry to the consultants that says, you know, put your stuff between the sandwich, and then I'll make sure the inner interface and the outer interface is not clashing. Okay. So how much time in percentage are you spending in Maya, Grasshopper, Revit at Saha? So it depends on the project. I work in different projects in parallel. If the project is in concept, I would say 80% Maya, 20% Grasshopper. If the project is in SD, we start having a little bit of 60% Grasshopper, 40% Maya. And then if it's DD, we start closing Maya and stay in Grasshopper. It's 80% Grasshopper. And maybe like it's 70% Grasshopper and 10% Revit and the other 20% Maya. And then when it's construction documentation, I do stay a lot in Rhino and Grasshopper to keep modeling, but I do need to make sure that everything is submitted in Revit. So yeah, that's more like 80% Grasshopper for me in there. So do you have time to explore new workflows and processes while working at Saha, or do you make this in your free time? No, when I'm at Saha, I need to work on the project. And then this is a bit more of a coffee time at 9.
You learn a lot solving problems.
Yeah. No,
you're inadvertently learning.
Yeah, I think, I mean, it's not like, I can open my teaching while I'm at Saha. It's more like, you think about problems, and then these problems, you see as potential as to do something else. I don't know. Like, some new ideas about like how to work out with some sort of topology, then maybe you have other ideas that can't be pushed because you have a lot of limitations in terms of construction. And in a free world of design, you could explore it. I would be super interested also to see how much it could be pushed in a virtual world. Some of these geometries, like I always think like construction is amazing when things get built, but like imagine that you don't have that constraint. It would be super cool to actually push design to the limit. Okay, and one more question. Do you use SketchUp? No, I don't open SketchUp.
That was a quick answer.
Yeah. I left SketchUp because it looks like dumb boxes. Yeah. Is Blender an alternative software to Maya, or Maya is more complete? I think like Blender, I don't use it much myself, but I know like it can be connected to Grasshopper and it's also polygon modeling. So I see it as a good alternative. I think, we do have a lot of in-house resources for Maya. A lot of like, you can script in Maya a lot as well, like Mel and Python. And we have a research group that has been building a lot of things for us. So I think that also over time builds up knowledge, and that's one of the reasons why Maya for us is important. Yeah, I could say Blender maybe. Which BIM software are used in Saha Studio? Revit, ArchiCAD, Revit and CATIA. I think CATIA is the old one. Revit is the one we use now. What's your view on Maya Mesh? Yeah, I don't know. Like, I think what you say, Mesh or Mesh in Maya. I think it's quite strong for what it does. But if you know Grasshopper, I don't see why you need Mesh. I think I prefer to have absolute control rather than having to navigate through the interface to understand how Maya wants me to give that geometry. But I know a lot of people use it. I don't see why not. I think for certain things it's quite fast. When are you doing your next webinar? That's a good one. I don't know.
Masters.
Yeah, the master. I don't know. Maybe we'll do one. No, I mean I know.
Yeah, more, yeah.
I know we'll do when is it? In January, no? We'll do the one, Radu will do one. So the other set of tutors will have another webinar.
Yes.
And then after that, I guess I will try to do one myself.
Yeah, there should be like one of these little teaser webinars for each of our like chapters and labs of master's degree.
Do you have a date for that?
I don't. but
Okay.
Catalina does.
Yeah, so I don't know. Well, somewhere next year. I don't think it's gonna be this year.
No, I mean, year's almost over.
Yeah, exactly.
The only thing we have coming up, no, it's not even this year. The beginning of next year, we have the CD Next conference.
Okay, yeah.
Yeah.
What are you guys gonna be doing?
It's lectures and shorter webinars as well.
We still have 2 more, no, next week.
Yeah, we have 2 more webinars next week.
I think like Madeline one, I think is a different scale. Like I super enjoy it, but like a bit connected to, I think the last one I did is Alejandra's.
Yeah.
Like in the sense that, I mean, it's slightly different with WASP.
Yeah,
but
aggregation.
But it's aggregation, so it's the next chapter. Like it's how this is gonna plug into the next chapter in the master.
And Madeline, he actually wrote his own plugin for the webinar.
Yeah, that's crazy. I read about it.
So you'll be using his own plugin, which is kind of cool because he won't be able to use it anywhere else. Like
so that's only open to the people who will be joining the webinar.
Yeah, for now. Yeah,
that's super cool. Yeah, I'm sure part of the master as well. So once you export from Maya to Rhino, I guess there is no coming back to Maya, right? Or do you find it necessary to get back? I do get back to Maya. Like, I mean, like if the geometry you receive from Maya, it is like anything you get from there is automated. There's no reason why you couldn't get back. But yeah, I think going from NURBS back to low poly is a bit tricky. With these new workflows of Rhino 7 with the sub-D, it looks a bit more promising. But yeah, I still find it a bit tricky going back. But I mean, naturally, I think like, you do a concept and you go to construction, you don't necessarily want to go back to concept. Ideally, the client is not asking you to get back to concept. Otherwise, you need to charge for more fees. Okay. There's still quite a few questions.
Should we see if anyone is brave enough to open their camera?
Oh yeah, that'll be great. If you guys can throw the questions.
If you raise your hand, I think there's a raise hand. If I'm not mistaken.
It used to be a raise hand, no?
Yeah.
Yeah, feel free to join us in the conversation. You can all switch on your cameras and we have a little chat. It's more dynamic, anyways.
I don't know if I can put them all on. It only lets me pick like people. I like see someone wants to go here, so I'm gonna do it. Okay. So I promote you to a panelist. So yeah, there we go. See if it's working there.
Hi there.
Hello.
Actually, I just put a stupid tape on my camera and take it off. I'm sorry.
That's okay.
I want to thank you so much, Alejandro, for the webinar. It was so interesting. As I told you in the comments, I've been installing Maya for 4 years. I've never had the chance to use it. In Morocco, we're more concentrated on ArchiCAD, Rhino, Grasshopper for modeling and stuff. And I currently am on my second year experience at YDA Architects in Tangier. And we start to, I took off the tape.
Oh, there you go. I can see you now.
Like, we're pretty tiring. As I told you, I've been discovering parametric architecture for like a couple months, 6 months right now. And we've been so glad we've won a couple competitions thanks to that. So yeah, I just have one more question. I've heard that Maya is useful also for rendering, but I guess 3ds beats it on that point, right?
Yeah, I would say so. I mean, like it's more like if you are doing your concept in Maya, you don't necessarily want to export everything back and forth between softwares. So that's the reason why I think people will keep it in Maya. But I mean, at the end of the day, you have Maxwell, you have V-Ray, you have Arno.
Yeah.
I would say the most like complete software for rendering is 3ds Max. I think that's arguable. But I do it in Rhino most of the times, to be honest.
Because I've seen a colleague doing basically the same things we've been doing in Maya, but in 3DX.
Oh, okay.
So I was just like wondering what's the difference between the two.
Well, I mean, I'm much slower in 3ds Max than in Maya. Like I don't see the same speed there, but yeah, I don't know, like maybe it's also an option to do these things in 3ds Max. I think at the end of the day, it's polygon modeling, and the software you use, that's up to you. Like I think there's a lot of softwares for every workflow. It's more about like, you know, like form finding. How do you do your form finding is a little bit up to you.
Exactly.
But at the end, it's like if you do this kind of like sketching in low poly, I bet like with Rhino also, like with SubD, it's gonna be perfectly an option, like to model directly in Rhino with this new SubD mode. Yeah, I don't know. It's just like, I think 3ds Max is, why not? I actually like haven't seen anyone modeling like super fast in 3ds Max, this kind of geometry, but it will be interesting to see.
Took him really a lot of time. like crazy geometry.
Well, looking forward to see what you can design with this.
But actually, I have a stupid laptop. I guess I'm just gonna work on it on my office laptop for this week. So I guess I won't have any output.
Well, anytime.
Whenever you have it.
Yeah, exactly.
Okay, thank you guys.
Thank you,
Thank you. I'll put you back to attendee.
Where can we find more resources to keep learning modeling architectural stuff in Maya? So, I mean, Maya, it's not because I teach it, but I really don't know any place where you can learn it other than webinars.
For Maya?
For Maya.
I mean, yeah, I mean, you can also just like look online. Like a lot of stuff online is based on like character design, but it's all applicable because characters need really good topology.
Yeah, but that's the trick, no? Because I think this workflow is quite specific for architecture. Yeah. A lot of the stuff when I was trying to learn a little bit Maya
the workflow,
myself, you know, it's like the geometries are not necessarily something that will be useful for architecture. Like, I mean, it depends. If you want to learn about topology or you want to learn about the tools themselves, that's fine. If it's about workflows for architecture, that's a bit more tricky.
Or come to our master's degree.
You just need to
and you'll be a master.
Exactly.
Because you know everyone that's teaching there is these kind of people. So should we bring in another person?
Yeah.
Let's do it.
I'll keep answering questions regarding
promote to panelists.
So we
have
one.
Guillermo here.
Oh, Guillermo. Yeah. Hello, Guillermo.
I think it takes them a second to like, because it like, I think it like makes them rejoin as a panelist.
Hello. Now you can see you guys. Yeah, thank you very much for everything. It's very interesting, the stuff you teach us.
Thank you, Guillermo.
I've been a lot of time right now in parametric architecture, but this workflow, it's new to me. The Maya, I tried to do form finding in Grasshopper and well, a lot of stuff in Rhino, but it's a lot more complex. And it's amazing. It's very easy, and I was like very slow when I tried to model in Maya, but it's very, very interesting. But guys, it would be amazing if you could teach us in another time some optimization. I do a lot of k-mean clustering, but you know, another type of optimization would be very interesting, because when I see some Zaha Hadid projects, like to have like just similar pieces in one project, it's very interesting how they do it. So it would be amazing.
Yeah. No, I mean, there's where do you work, Guillermo? Or what do you do?
I am a parametric architect at Sordo Matalenos in Mexico City.
Okay.
Yeah.
Okay.
I'm
Cool.
the chief of the chief of design, but it's Mexico, so
Yeah.
it's not as advanced as Saharit,
No, I
but
mean,
we tried.
no, of course, of course.
Yeah.
No, yeah, no, definitely. I think like I had the same issue like when I first I remember like using Rhinovolt and Kangaroo, and after my thesis, trying to find like how do you get to these kind of shapes, and at some point I was so frustrated because you have to do this whole script like that, like to get to something that was like a little bit, something a little bit, but it wasn't like I could actually design it. It was more like pure form finding, and I felt like I was lacking a little bit on the freedom, like to actually like do exactly what I wanted to do. Like I knew what I wanted to do, but I had to spend a lot of time on thinking, where to put the supports and where to put the, all the conditions for the geometry to do what I wanted to do. And actually what I want to do is to do my design, be super happy about the design, and then we'll see how we build it. Yeah. So like I took that step back, went through learning process. I mean, it wasn't easy for me to learn Maya, I must say. It took a lot of time to do it on my own, but I think like it gives you that freedom. And now there is, I think like you guys, I'm super jealous. Like you guys are so lucky that there are all these kind of webinars, and I think it's starting to be a bit more popular now to use it, and you have webinars out there to learn this. Before it was I had nothing like
Yes, we're lucky.
I could see like how to bridge two cylinders, and try to think how to do a building from there.
Yes, of course.
But now it's very good. And in terms of optimization, I think it's the problem of that is like, I mean, from one side, like there's a lot of in-house tools for some of some of that workflow, which we can't solve. Anything that is kind of in-house developed, like we can't really use it for webinars. So we'll have to think it like how to do it with basic Grasshopper elements. And then the other one is like it is advanced, it is more advanced. So I think as part of like something specific where there is an interest of a big group of people, like we could think about it, like for this kind of very general kind of workflows. I think this is already quite specific. I think other webinars I've seen, like it is a bit more superficial. This gets already into a little bit of detail. It's not just like an object that you add loops, but actually you have a bit of control. And it's hard to get into the more complex stuff in this format of 5 hours webinar.
Yes,
I mean, of course, in another kind of format, like let's say I do, like the design morphine master is going to be a great platform, like for me, for instance, to prepare a little bit more of that. Like in B-Pro, when I'm teaching there, like there's a bit more time. We do workshops that are like 2-3 weeks. So then in 2-3 weeks, you can teach more, like you can take it in steps. But otherwise it's a bit difficult, like as a format to explain something a bit more complex. But yeah, glad you enjoy it, Guillermo.
It was amazing. Thank you very much. And whatever you need, you have my Instagram. Thank you very much.
Thank you for joining.
Thank you for
Thanks
joining.
to you guys.
Okay, I mean, there's a lot of questions here. Question regarding the master degree.
Let's save that one for a minute.
Okay. Alejandro, in your opinion, with upcoming of Rhino inside Revit, do we still need Dynamo? I guess that's the question. I don't do Dynamo. I do Grasshopper. Dynamo, I think it's good for managing a Revit model. So I think that's still going to be there. I don't know if Rhino Insight will be covering things about, you know, layouts and templates in Revit. I think they were going to bring some of that, but I think from what I understood, the interest of Rhino is to still be on generating geometry, and then the you know, managing your drawing documentation will still be done through Dynamo. So hope that answered the question.
Should we invite one more person?
Yeah.
Okay, this will be our last live question here. It's Radu.
Hi there.
Hello.
Hi, Alejandro. First of all, thanks for sharing all your beautiful insights. It's been really amazing. I just wanted to say from my background, like I'm also an architect, but haven't worked in architecture that long. I've been doing motion graphics.
Oh, that's amazing.
Maya at the beginning. Used a lot of Cinema 4D. You know, it has a lot of procedural tools. I think kind of new workflow is inspired from motion graphics in a way.
Totally.
I see a really big potential for this kind of design techniques to be used in virtual sets. Like recently, we're doing virtual productions. We're already starting to think about it like virtual architecture in a way. Like
No, I think there's going to be like a big thing, you know, virtual architecture.
If you at Zaha are in a way thinking about these new technologies like VR and AR.
100%. We have a VR department. So specifically, we have a VR department that it's developing a lot of in-house tools for us.
That was formed recently, like officially, right? It's called like ZHVR or something.
Yeah,
like officially they got a name.
But I think they've been out there for like 3 years, and I think it became official like 2 years ago. It's a small team. It's not a big team, but I think there is a big interest also with all the thesis of Patrick Schumacher about you know, the way users navigate a space. So I think there's a lot of like, just by simulating, like even if you think about, you know, traditional architecture, especially when it comes to workspace and big projects like you know, Sberbank. Sberbank is one headquarters that we had in Russia with like, I think it was 10 to 14,000 people are going to be working there. So we need to simulate how these people are going to interact with each other. So we have a team, like research team, working on simulating how all these people are going to navigate the space and how they're going to be interacting with each other. And we have a team that it's kind of visualizing that. And like, basically it's not even like you're modeling that much. It's a lot of like data coming and things coming automatically in VR. So it's about like, you know, data streaming between the softwares and then how you export that to VR. And yeah, I mean, I don't know how much I can talk about it. Yeah, definitely.
Is like building something eventually. A lot of people were asking in the questions when you were designing all these complex shapes, how can you build them? But I'm working in a field where all these constraints from reality don't really exist.
Yeah, I envy you.
Yeah, I'm about to design some really cool stuff with what I've learned today. So thanks.
Okay. Well, like I hope to see like what you're gonna be up to. I'm sure like it's gonna be exciting. I actually think like, you know, like that's a big one. Like that's being able to design, but like to the extreme, virtual spaces where you can really explore, you know, the space qualities of what you're doing. Because at the end of the day, it's, you know, the brain, it is wired, so you have like certain inputs, and then your experience as a user, that's what architecture for me it's about. Of course there is the construction part, but I think at the end of the day it's about, you know, the experience of the end user. So I think, you know, that can be explored in a virtual space as much as it can be explored in a physical space. So yeah, I think you're going to be part of, you know, like
can go
super
not just in
generation.
this world, but out of this world now.
Yeah, exactly.
Conceptual spaces. Like
yeah, absolutely. No, motion graphics is like, I think that's one of the main places of the main source of inspiration for workflows. I think they are way ahead than architects when it comes to managing complex geometry.
I encourage all architects to look at this kind of new workflow, like learn new software and not be afraid of what you can do.
So what's your main kind of like software at the moment?
Like what I do?
Yeah, like I mean, which software like would you
I use Cinema 4D. I've tried some workflows like this with Grasshopper. Also, because it's motion, we use Houdini sometimes.
Houdini, okay.
So we use these kinds of paneling, but the panels were also moving, you know, dynamically. Like this was for festivals and visuals, like really far out. But now you can design spaces and put people inside them and make these virtual sets. And this is perfect for this.
Super cool. Yeah. No, I think I'm always like working in this kind of morphing world. I do think like I need to move to 4 dimensions like at some point for my research. So maybe a little bit more motion graphics, because I think that there is all these parameters controlling conditions, and it will be quite interesting to see how, you know, how that becomes part of an experience. Just haven't had the time to get there. I still need to deliver projects in the office.
You got the right mindset. You're on the right path. Yeah. Who knows what the future has?
Yeah, 100%. Thank you, Radu.
Thanks a lot.
Okay, maybe, I don't know, should I have a few questions more, and I think then we're done.
Yeah.
So how
I was going to actually I was actually going to have Kathleen answer the master's question.
Yeah, well, yeah, that'd be amazing.
You want to answer? She's here.
Hey, how are you guys doing? Yeah, Alec, how are you doing?
Pavlina.
Exciting stuff.
Very excited. I think we had a lot of questions.
Yeah, well, that's good.
I never had so much engagement. That's great.
Yeah. Well, I see here a question about the master's degree program, which is about like successful applicants and what does that entail. So basically, I would say that like this master's degree is open to anyone who would like to explore, you know, computational design and advanced design. You know, of course, a 3D background always helps. So if you know Rhino or Maya, you know, like that's a very good base to start. Also with design morphing, our expertise, I would say, it's a bit of working with people who actually are just starting. So we don't shy away from that challenge, you know, like working with people who are not pros in the field, but definitely you have to have a strong creative drive. There is going to be, it's a plus definitely if you have worked with different scales of design. So if you've worked with jewelry, for instance, and architecture, you know, it's a totally different understanding. And also, you know, like it's even a bigger plus if you've ventured into Grasshopper and generative design processes and parametric design. But I would say that like the most important thing is, you know, like to show that you're collaborative, that you're excited to be part of, you know, a team, because that's how like we work with design morphing, you know, like we are part of this community, and that means a lot to us. So definitely, like if you're a team player, that's a very big plus. Ale, if you have anything other to add to this?
No, I think it's you know, it's more attitude rather than aptitudes. So, you know, like the software is what we're gonna bring to the mix, and then you need to bring your will, eager, and motivation, and I think
your passion.
Yeah, your passion. Yeah, I mean, it's going to be a lot of time, like for you guys as well, and a lot of effort. So, like, you're gonna learn tons. I think, like, it's amazing. Like, usually, like, you'll have like tutors that are always more geared towards the same idea. I think what Design Morphine is bringing here is such a super rich mix of people doing different stuff. And somehow, like, it's all under the same umbrella, under the same brief. I think that's amazing opportunity, like, to be able to navigate through all these different workflows. It's pretty much like a lot like workflow based, and there's a brief, like, kind of creating the umbrella, but like you're just gonna be learning like so much from like from the very small scale to the super large scale.
And you'll be making your own scenario, which is cool, you know, writing your own sci-fi book.
That's
like
cool.
going through different chapters and envisioning what the future might entail, starting from the human body and building up in complexity, like Alejandro here is showing, like the second stage, you know, this webinar has been inspired by this second stage of the masters. So, you know, like, and it's building up in complexity while it's building up like in scale. So I think that that's like the unique part of it. Well, thank you so much, Alejandro. And so thank you so much to the whole team. It's always a pleasure.
Thank you, Paulina.
Goodbye.
Okay, so that one is answered. I have a question here about how we're going to keep up innovating at Zaha Hadid.
I think it should be the last question because we're like an hour over, right?
Yeah. Yeah, it keeps going otherwise. Yeah. So I think, I mean, that's, I mean, I don't know if I'm on the position to answer questions about how we're going to keep up innovation, but I think, you know, the spirit of Zaha, it's still there. Like there is like a lot of like talent and this idea of being studio based and everyone kind of helping and contributing to the long-term research agenda. So things like ideas keeps coming, like, and I think we have more projects than ever, which is very exciting. More directions. I think for me, like, you know, like, of course, I wish like she was still there. Like there is not that kind of like kind of big person on top that brings everything top down. Right now, there's a lot more of like bottom up, but I think it was always there. Like I wasn't there, unfortunately, at the time, but it was always there. Like everyone was a creative person and everyone was bringing designs. It was just this one person on top taking decisions. Now we still like super bottom up. I think it's more bottom up than ever. So everyone that comes to Zaha like has a big opportunity to make an impact in the office. And you know, those that work hard and like keep pushing boundaries, like they are rewarded eventually. But yeah, I think like I don't see how that will impact basically. But yeah, I think like, you know, director will be more in the position to answer the question. That's my humble opinion. Okay, so
yeah, I think
I don't know.
Wrap it up.
I think that's good, no? 1 year.
Yeah.
Okay.
So
thanks to everyone.
Thank you all for joining. You'll get an email after this on how to access the recording, and it just has to process that was explained in the previous email. And you'll also get an email for getting your certificate. And remember, anything you do, if you want it on a website, you can send it to results@designmorphine.com.
Cool. Yeah. Remember to tag us in your stories and posts and stuff.
Yeah. Cool.
Okay. Cool.
All right. I'm going to end it.
Yeah.
Thank you.
Ciao. Ciao, Mike. Bye.